Hello, hello. Let's continue with Runic here. So last stream I noticed a bug and I've kind of pinpointed to the issue. Well, I'm trying to find it anyway. It's kind of weird because I'm just running this file. Actually, yeah, this is the only file that's like I'm trying to run here. And it's basically if I comment this out, this runs without issues. However, if I add this here, there is a bunch of leaked memory for one, but then there's also yeah, I was like, how could this affect whatever? But then I realized, okay, well, it is actually trying to execute this here. So we have like lookup s, and then I'm improving the lookup debugging here so we can see what's happening. So we got blocked, which means there's, yeah, it wasn't found basically in this scope. So yeah, and that makes sense because this variable is basically, it doesn't exist. So yeah, that's what's happening. But then I'm trying to figure out why are we not showing an error message, and why is this just jumping straight to deinitialize the main scope here, and then we get, and also why do we get leaks? So yeah, that's what I'm looking at right now. All right. Okay, so then we need to look at where this is called from. This is coming from somewhere. Valid. Okay, also another thing that I want to add, basically everywhere, because everywhere I almost have like this everywhere that I'm curious which functions get called, and with some data as well. So we have this log at the start of every function almost, or many of the functions, but then we don't have if it reports an error. So you can do this, you can have error defer, and then you can catch the error here, and then you log out, yeah, this reported some kind of error. And this should work in all, this kind of statement should work in like all different kinds of scenarios, because we're taking the function name that is generic, we just put the error there and the error there. So that this line of code is like, it should work everywhere. So I'm basically gonna just put that everywhere where we are kind of logging the stuff. So yeah, I could just like put it everywhere basically. Pop frame. I mean, we can even put it at the top, or yeah, I guess we put it here usually, I guess. So basically everywhere where we do that, we will do error defer, detach. Where's the log? Okay. Right, because we're logging from detached. Sure, whatever. Log bindings. Now the initialize functions, we don't need to have error defers. All the functions that has errors. What is this? Expected error unit type found. What? Okay, now I'm confused. Is this because of this statement? Yes. Do we have to return the error or what? No. What's happening here? What? Okay, hang on 1 second. Alright, it was nothing. I thought I heard something. Yeah, the cat's going crazy here. Why is this happening here? This is weird. And if I move the Erdifer over here, it works. But then it doesn't like I want it to also be here. Okay, maybe there's something about Erdifers that I don't understand. I'm going to go to the zig documentation. Erdifer. In addition to defer, zig has Erdifer evaluates the deferred expression of block exit path if and only if the function returns with an error from the block. Erdifer. Yeah, see here? They're doing the same thing, like return some kind of error. Can optionally capture the error. I mean, and then we even know the type of the error from it. It's not inferred. Even here, they do it before the return error, and they don't. They also infer the error type. So, what is the issue with what I was doing? I don't understand. Okay, tidbits about error handling. Primitives gives enough expressiveness that it's completely practical to have failing to check for an error to be a compiler error. If you really want to ignore the error, you can add catch unreachable and get the added benefit of crashing in debug and release safe modes if your assumption was wrong. Yes. Since Zig understands error types, you can pre-weight branches in favor of errors not occurring. Just a small optimization benefit that is not available in other languages. Yeah, that's really cool, actually. I didn't think about that. That's really nice. But yeah, let's see. Not sure. Okay, so then I don't know why I get an error here. Because this type here is the same type as this. Expected error union type. Yeah, this is an error union. It's like it's saying that it got an error set here, which is not the case. Is there something weird with syntax here? I don't think so. What if we just do this, just in case? No, still get the error. Because that is definitely not an error set. And what if we say error? Found type. Expected error. Yeah. What? Okay, what if we put this the first thing here? Why do we only get it here as well? We should get it like this also can return an error. I guess it's like an error union. This returns an error union. This just returns the error itself. I mean, that should work, right? This is how you're supposed to do it. It doesn't complain if we don't have the error defer. Will this also? Yeah. Okay, that works. But that's so weird. Why can't I refer to this error here? Or do I have to say like error dot? No. What the hell? So is this the way to do it? Hang on. Errors. Yo, Roland. What's up? Do you know this? Error union. Error defer. Right, so here they're actually saying like lowercase error. I would think it's better to like, I mean, I don't know. I would think this it's like the same thing, but also you get like the auto completion of what errors you can have. Error set is like an enum. With each error name across the entire composition gets assigned to the unsigned integer greater than 0. You are allowed to declare the same error name more than once. If you do, it gets assigned the same integer value. Right, so that I've figured out that much. Like if an error has like, you just need the name. It doesn't matter which set it comes from. The name is what's important. Which does make sense and eliminates a lot of confusion. Because there's a lot of errors in the standard library that has like the same name, but they come from different sets. Like the find not found error, for example, exists in a couple of different places. Yeah, and here you can also see like out of memory That's that's exactly the same error, even though it's like defined in different sets. So you can think of this as just a collection of strings, basically. But what is the issue with, like, because you can type like, yeah, I want to return file open error dot file not found, for example. I've been able to return that before. It's only a problem now. Maybe it's a bug in the compiler or something. Hang on, I'm just gonna let the cat out here. Wait a second. Alright, cat was going crazy. Yeah, alright. Yeah, and here we're like coarse superset to subset. You cannot coerce an error from a superset to a subset. What does this mean then? What is this expression? Coerce subset to superset. You can coerce a subset to a superset. So superset would be you take something and it has like stuff surrounding it. Coerce subset to superset. So this is apparently a subset, which doesn't make sense to me. I would think this is an actual error, literal, and not a set. I'm confused. And then to a superset. So then this type is the set. This is like an enum. Oh, right. Okay, so this takes this, but this implies that this is actually the inner. Yeah, I think it's just a compiler bug or something, because it's like it is possible. So basically here. Yeah, if I have uppercase here, apparently this is now an error, but it's not an error if I don't have the defer. Now it's all of a sudden it's not an error. Or I mean we're returning an error, but it's not, you know, there's not a compiler error here. So that feels like a compiler bug to me. Like we introduce defer and all of a sudden we get some error here. This doesn't make sense. All right, well, let's just live with having lowercase, I guess, because I do want to have this defer. Also, I think it's probably better if we have it like on the, like at the top on everything. Definitely. Finding frame, we don't have a log for that. Well, I guess maybe not needed. Maybe closure we definitely want. Let's just go through everything here. So here's frame, the initialized frame, but that does not report an error. This one does report an error, but it's a log binding, so detach. Yeah. I've only been learning programming, but I enjoy doing it alongside with someone, so I listen to your commentary in the background. Yeah. I feel you. I usually have like a, if I don't stream, I have like a video in the background while I do stuff. Unless I want to really focus, because sometimes I just get too distracted. Let's see. Yeah, detached log push frame. Let's move this up. Let's have it always at the start. That it makes a lot of sense actually. Declare. Yeah, okay, that's it. So now we've got erdifers in all the different functions in scope. And that has logging. So if we run this again, do we see anything else now? No. It's just blocking returning null. Okay, so then let's do the same for the evaluator. There's gonna be a lot of these. I guess we can search for self log. Oh. Yo, SQF. Why didn't you stream yesterday? I did stream yesterday. I even told you in Discord that I was going to stream. So you missed it. I told you like, yeah, I'm gonna stream now. And then I went to stream. But I think you were like offline maybe. Yeah, but and also as I said on Discord, like I usually don't stream on weekends because I have a family, so I'm, you know, I can only stream like basically on like when I have time over, on working hours basically, and some evenings when I have like extra time. Hello, piano coder. Yo, what's up? Bash-like scripting language, yeah. Yes, yes, yes. That is what we're doing. Are you a developer as well? I mean, you have coder in your name, so I would assume. Yeah, makes sense, SKF. No problem. So if you wanna check it out, it is available somewhere. A value pipeline, yes. And there we go. That's it. Let's do command runner as well. Okay. No. There we go. I think. Yeah. Okay. All right. Now we get a whole bunch of errors here. Okay, this is so weird. This is like an official standard function. We catch the error, we switch on it. If we get else, we return it, and then apparently this is an error now. Yeah, I haven't seen Zig before. Looks like C. Yeah, I mean it's very close to C in like what it can do, or like the features. But it's like more modern, I guess you could say. What's the theme? The color scheme is called Melange. Spelled like this. Access denied? No. So see, the error here is like, it's a compiler error. So the compiler is complaining that we have the wrong type here. And in Zig you have something called the error union type, because you return errors in contrast to C, where you would return, you know, 0 on success and like an error code otherwise. But here it's like the errors are actually like typed, and you have then error union type, which is basically a union type. It could be either an error or it could be, you know, the result. And this type here is like it's an error set, which is one, it's like your error is one of these errors in this specific instance, in this specific type here. So it could be any of these errors, but what it's complaining about is kind of weird. I think this is like a compiler bug, because I'm trying to use a construct called defer, which will run this code if we return an error. And as far as I can see, I am using it the way they show it in the documentation. And also, there's no issue if I omit this. Now there's no error here anymore. But if I introduce this statement, now all of a sudden there's an error over here, which says that it expects the error union type, but it found this error. So this is, I mean, this is an error. So all right, SQF, no problem. Okay, so that explains a bit. I did stream, but maybe, okay, when you were asleep then. That makes sense. Yeah, so I don't know why we get this error, but it feels like a compiler error. And it feels like now we can't really fix this issue here, because this error is like, unless you can do something like this. No, that won't work. Found a type. What? And that won't work. Found error type error.er. No, okay. I have no idea. Alright, cool. Yeah, I mean, you seem to understand fine, so that's. I didn't know this, to be honest. Yo, Borochecker, what's up? Yeah, man, this is annoying. I mean, is it because we're trying to capture it and then trying to print it out? Like, what if we didn't capture it? I just want to show which error it is. Okay, now there's no error. Monadic errors are up. Yeah, I mean, it is like an either type from Haskell, a union. Okay, but I do want to show the kind of error we get, but I guess we don't have it. What if you put like any here? No. So I guess like just the act of capturing it creates this error. Okay, well, let's just live with this now, I guess. We can't actually fix this unless we put this in another function, maybe. Okay, whatever. Well, it's gonna get reported somewhere anyway, I think. And then now we have to change all of these to lowercase error because of the bug. I'm just gonna assume this is a bug in Zig. I've never seen this before, but then again, I don't really use defer for this purpose. Yeah, and actually never used this kind of statement before where we capture the error. And that seems to mess things up. But okay, let's hope that there's nothing, like there's no bug in the thing. What plugin shows the diagnostics dialog? This one. No, F8. Diagnostic, go to next. I don't know really. I mean, it could be just the built-in stuff. I'm not sure actually. But this is NeoVim, so I'm not sure if you're. It's probably different from. Well, it is different from Vim. What language is this? Looks at random things. It's Zig. How long have you been using this language? For about a year now. A little bit more than a year now, actually. It's like a better C, I would say. Even though I have not programmed in C, but I've seen a lot of C and I've dealt with things very adjacent to C and everything. Even Zig has C compatibility, so you can import C libraries into Zig. But I would just argue that basically all features of C can be replaced with features of Zig, but they are better basically. Oh, you have Neovim, but you don't have it. Oh, wait. I think it's telescope actually. It's telescope. Look into telescope plugin. Telescope is an amazing plugin, by the way, for Neovim. Okay, that's what I use for like finding files, and there's like a live grep to find, you know, strings and stuff. And I think it's telescope that I've bound to that thing. Okay, there's no more errors, so now hopefully we will see an error trace somewhere. Where's the thing? Here we go. Okay, here we go. So here's the error trace going backwards now. Okay, cool. So we're trying to look up S. Let me show you the code here. So basically the code is this. We have like var myString, we have function, echo some stuff, and then we set S to something, but S is not defined. So I am trying to find out what S is doing here. So, or what this expression will evaluate into. So we have S, and this problem is going to disappear, I guess, in the semantic lookup instead, like the semantic analyzer. The semantic analyzer will prevent this from being executed at all. But now I want to fix it because we don't have a semantic analyzer yet. Okay, so we don't see any S, which we don't get, and now we get unknown identifier, which bubbles up into somewhere, into run statement of evaluator. So why is this not like bubbled up even further, is the question. No, it's where this is called from, right? Which would be here. So, all right, we're catching it and we're trying to render the error here. Okay, I see. But why are we not seeing it then? Script execution error. We should see a script execution error. Wait, okay, I see. Maybe this gets removed or something. We should get some kind of error. It's like we don't get anything, basically. We just get a bunch of leaks. And this is only used in there, so let's just get it. Let's just get it from here, actually. It should show up here, like. I mean, we could also No, because this error is actually, yeah, the error should be forwarded. Maybe it's like blocked in the current scope. Maybe that's why, like, we're not popping the scope. So it gets forwarded into, but that makes sense. Like we don't have like proper error handling inside a function yet. So it actually makes sense that we would get the like, okay, if something goes wrong inside a function, it depends on the context what we do. It's like you can have a catch, for example. We don't have that right now, but basically that's what you could do, basically. So actually, yeah. But this is more like this is more like a semantic error in this case. So it would get caught before, really. But if you would, let's say you execute another like program that fails, then we would have a kind of the same issue here. So there's a little bit work there to be done with handling errors inside function calls. Right now I just want to see the error though. Are you gonna sell this program you're trying to make? Where will you use it? Are you writing a script to specific location, or just learning? So basically, I'm writing this as a learning experience for me personally, and I'm showing the process so that maybe others can learn stuff as well. And I like Zig, so I'm building it in Zig to get better at Zig, and because I really like Zig. And it's also kind of, right now it's like a toy language for me, but it's also, it could grow into something that others can use maybe. And then also I am gonna replace my kind of basics bash scripts that I have, like, because I've been using like bash scripts more and more, and that's the reason why I wanted to make this, is because I don't want to have to learn all the bash syntax and everything. So I just like, yeah, I'm just gonna make kind of like a more programming languagey scripting language, so to speak. So so that's what's going on. So yeah, so yeah, so it's basic. It's very it's made for me, but then also others can use it if they want. There is an yeah, it's basically, it could be an open source project. Like right now, it's, you know, it's on GitHub. It's public repository, so you could go and check it out if you want. Yeah. Okay, but what do we do with this? Like, we get an error, we render it to standard error. That seems like the correct path to do. It's just that it gets lost and then we return. It gets put into standard error, but then we don't really have a handler that will take that message and put it into our like outermost context. So really, I'm just wondering if we should defer pop the scope. Because that will kind of take care of the problem, maybe. You know what? I'm just gonna right now. I'm just gonna write this to actual standard error instead. Like, I'll add a to-do here. Redirect properly when error handling is implemented for function calls, and blocks, etc. So I'm just gonna do standard file writer and then we don't do this. We will do file writer dot interface. There we go. So now it should show somewhere. Yeah, now it shows here. Now we're seeing this. Okay, cool. And let's see. Next is the leaks here. I'm not sure why we're getting these leaks, but it's leaking from like command runner. So basically it's when we're in command runner, we create it never goes through. So we have, all right, so here's the command runner. So we're running the pipeline echo, right? But there should also be a command runner for the function as well, which is up here. Run pipeline, run function. Yeah, here's the function run call. Yeah, in the description. Yeah, the repo is there. So here's the function call, and when this errors out, it seems like we don't take care. Like we do, we should take care of the captures. Maybe we never take care of these. Or I mean, yeah, these ones. Let's just try doing this. We go to command runner, and we have like the Erdifer here. No. Where's the thing? Wait, or is this the actual place? Ah, here we go. I think, yeah, here we go. So these ones, Erdifer these. If something goes wrong in run pipeline, but it okay. It never seems to do that actually. It never gets in, it never logs out. So when we run, are we catching it? No, we're just returning a handle. Yeah, here we do like try run stage. And this never reports an error either. And then we run. Let's say, yeah, we're running the function. Yes, that's what we're doing, which could return an error. And then we run the function here, which could be an error. Oh, here we're kind of catching the error here and putting it in the exit code. I see, I see. Yeah, I mean, I can understand that it's confusing if you're coming from like C, because it is a lot different. So basically what I'm doing, I'm trying to so basically, okay, Let me try and explain a little bit. So functions in Zig can return errors like this. If it doesn't have like the error type, it would look like this. And now we can, it basically, it's saying that, yeah, this never errors, basically. So it never, you could kind of also call it like it never throws an exception. This now says that, yeah, it could be this kind of error here. And this error is defined here to be, you can have these kind of errors or any of these kind of errors. So we're defining the error type as being a bunch of different error, you know, what errors are that could happen here. Okay, this is in the same file here. So we could have like a bunch like allocation errors, we could have reader errors, file writer errors, and so on and so forth. Okay, so this function could error with any of those errors. So in contrast to C, you would just return an int or whatever, or a char or byte or whatever you call it, and then or an int, I guess, maybe. And then it would return like 0 for success, or something else, some kind of code error, blah blah blah. Oops, what am I doing? Int return 0 success or return error, blah blah blah, which is like defined somewhere. Error, right? And then the caller would have to kind of know which error you want to look at. But in Zig, it's typed, so it's very, you know, it's very easy to see. Like, okay, this function can return this error. Okay, and then you can even match, or not pattern match, but you can check which of the errors it is. You can see the errors because of this function. Yeah, you can see that this could result in an error, this function. So it's like, I think Java has a similar concept with the keyword throws, I believe, which explicitly says which exceptions that can get thrown in the function, which is very nice. I'm talking about like the definition of like part of the signature of the function, that it says that, yeah, this function can throw these and these things. I'm pretty sure Java says throws. Like throw is for actually throwing the exception, but throws is for defining which exceptions you can throw. Well, it doesn't work like exceptions anyway. But how it works is basically, this is just a union type. And yeah, I think they have had it for like a while. I haven't looked at Java for like, I don't know how many years. So yeah, I just remember that when I used it one time, or looked at it one time. So yeah, so this type is just a union. It can be either an error or a stage execution. If it's an error, then you know you got an error. So this is just a return type. So we just return, you know, error access denied. So that's how you kind of throw an error, quote unquote. And then if you call a function that could return an error, so result equals could return error. Now the result would be, let's say it's this type here. So how do you now catch it, or yeah, how do you deal with this? So either you can do catch error, and you would get the error out here, and then in this block error would be available as this identifier. So you would be able to say like, you know, if we want to log out the error, for example, got an error, and we log it out, for example, and then you can return, I don't know, you can return null, or you can return the error as well. Also optionals, we're not going to get into that right now, but you can't return null from this because this is not an optional type. But I'm just confusing you here. But you can catch, and now this type will actually be the actual result type, because in the case of an error, we actually catch and return something else. So then you can use result freely as the you can like assume that this will be a successful value down here. Now result here is the value, like a valid value, because no error was thrown. Yeah. And there is also another construct where you could say, let's say we don't handle the error here, but you want to bubble it up to the parent. So then you could do catch error, return error. That just bubbles it up to the parent, right? Or to the caller, I mean. If you get error, this function says what is the error and catches the error. It's just the return type. This is just the return type. It just says that this function could return either an error or a valid value. Or I mean a successful, you know, result, which is this one here. This type for this function. Yeah, if you want to throw an error, you just return an error. So now this is like throwing here. So it's like instead of throwing, because throwing is like throwing and catching, that kind of setup is different from this, because the throwing and trying, or yeah, throwing, try, catch, that whole thing is like, it's more like a hidden control flow. Because if you throw here, well, it's like this. Well, for one, in Zig you would know exactly what function can error, and if you get a result from a function that can error, you have to handle it, because otherwise there is a compiler error. If you just did this, for example, and then assume that result is like the valid value, and you try to, you know, do something with the name, you can't do this, because this type is not the successful, like this type here. It could be anything. So it could be like the union, or I mean it's the union type. So it could be an error or a thing. And if you don't handle it, then you got a compile error saying that, hey, you have to handle the error here. So you have to handle the error in every step. So in contrast to throw and throw and catch, which is like you don't really, you can have several layers of function calls, a call stack where you don't actually see anything about errors anywhere. It just gets bubbled up to somewhere where you don't really have any idea of what's happening, unless you like go through everything. But here's very explicit, and it's very nice. So yeah, another way to say it is saying errors as return types or values. So but anyway, if you want it to bubble up, you don't want to catch it here, you can catch this call error and return it. If it becomes an error, we just return it. Otherwise, we will store the result in here. And so this is a very common pattern. So it's so common that there's a equivalent shorthand, which is called try here. So this would bubble up. This is exactly the same statement here, or expression here. These two are exactly the same. It's just that this is like a shorthand. So when you see this, it's just like, yeah, this could be an error. If it's an error, we bubble it up to the caller. And what I'm trying to figure out is the error handler. So the way you also then could do, let's say you want to have like an allocated, I don't know, array of some sort, and then you have like an allocator where you allocate a string or something like this, and then you have to try this to otherwise it's like an error. But anyway, that's not the. So basically, let's say we succeed, we get an allocated array. Now we want to do some stuff with the allocator, so we're like, you know, doing some stuff with the allocator here. But however, what if something goes wrong along the way? Well, now we have an allocated array that we're kind of leaking because we never clean up the array. Now what you can do is you can, if let's say for example you want to use this array later when you return from the function, but if something goes wrong in here, we want to have a cleanup function that cleans up all the resources that were used during the call. So then you can have an defer, which will then, let's say we just want to free the array. So you can have an defer. Now what this will do is it will run this code at every exit point that results in an error. So whenever you run a code down here and you get an error, this code will release, or it will clean up this this thing here, which is a really nice way of handling, like it's basically like an error handler for this specific resource here. You can catch error and return error, so you can use this error. Yeah, it's just bubbling the error up to the caller, so the caller has to handle the error when you do like try. So if this error's up, it means that this function will return the error, and then the caller would have to handle it. Okay, now what I'm trying to figure out here is why the defers, or yeah, I'm trying to add some debugging stuff. Basically, I'm trying to figure out why we have leaks, and I'm trying to figure out where I could put defers to clean up the leaks. That's what I'm trying to do. So there we go. Now you have some context of what's going on here. And what's happening is that we are running an executable which does a bunch of stuff. But the thing that leaks is this here. We're running a pipeline. So in Bash and in Bash basically, and this language, Runic, you have pipelines which looks like this. You know, echo hello into cat. This is a pipeline, right? And when we run this pipeline, we set up a bunch of stuff, and some of the stuff gets leaked. So that's what's going on. These things get leaked. Stage statuses, and see here we have an defer handler that frees up these if something goes wrong. However, it doesn't go wrong in here. And that was I was trying to figure out, okay, why doesn't it go wrong in here? So what's happening is we run each stage. We could have several stages. And then we run a function in this case. But then, here we run the function, but we catch the value. Now you can also catch with if else. So it's like if you have if, you capture out, and if you have if on an error union type, you catch the error in the else, and then you can also like grab the error type here. Now this is kind of convoluted how I did this here. I'm not sure what I was doing here, but I basically wanted to capture the result in some kind of thing. So I defined this type here, so it can either be like success or error. This is basically just an error type, to be honest. So yeah, I'm not sure what I'm doing here. This is really, I was just trying to quickly fix an issue here. You researched them while you were writing the code. Okay, cool. Okay, nice. So, but you were a C programmer, right? I'm just gonna refill my coffee by right back. All right. Okay. Pub function main. Defer file close. Yeah, I mean, yeah. Then you're kind of bubbling up to like the, I guess, error handler, like the global error handler of your program, because you're throwing an error, or I shouldn't say throwing because it's kind of the wrong terminology, but you're returning an error from main. So then there's like I suppose there's like an error handler for the program that would handle that error. So yeah, you could that's a valid program that you have right there. Except handle isn't used, so you're gonna have a compiler error. But basically, yeah. So usually you would like catch the error at some point and handle it, like displaying an error or whatever. Now this part is like, okay, this is like because this, so in the language, when you call a function and there's an error in the function, we don't have proper handling of that yet. So and this is part of it. So this is why we don't see the error bubbling up, because we're kind of catching it here and putting it in the result, which makes sense in a way because we want to be able to use, we don't always want to like bubble the error up if a function call has an error in it. So we want to store the error in the exit code. So that's the thing, like we have basically like a typed exit code, you could say, where the exit code could either be success, which is equivalent to like 0 in normal programs, or you could have a byte which would be equivalent to some kind of positive integer. That is, you know, how programs work. They could produce a byte exit code. If it's 0, it's success. If it's anything else, it's an error. And then, but then we also have this, which is like a zig error. So you can produce an error here as well. However, I'm gonna change this because I want runic errors to support more than just a string. So I'm gonna change this type later to be some kind of value instead, like an error value type. So, but anyway, yeah. So we're storing the exit code here. This is stored in the like execution result of the function, and then it's basically forgotten because of how this is working right now. Okay, but that explains why we don't see anything. But let's see, and also it explains why we don't clean up the stages. Because okay, we should okay, let's just defer here. Let's defer scopes, pop frames. 3. If something goes wrong, we want to clean these up. Let's see if that fixes the issue. No, oh, well, there's an error somewhere. Error unions ignored. All right, let's just catch and there we go. Okay, we still get errors. Or leaks here. UTF-8. I can't get away. Use byte U8. No, U8 is just it's a type that represents a byte, like an unsigned integer with 8 bits. And U16 would be 16 bits. U32 would be 32 bits. Okay, I actually have to leave for a little bit, but I will be back in about an hour. So I'll just leave this on here, and I will, let's see. Well, it's not memory saving actually. It's more like exit codes in real executables in programs. Actually, they are always a byte. Well, I guess it depends on the operating system maybe, but normally it's just a byte that you can return as an exit code of a process. Anyway, I need to go now, so I have to leave here. Let me just do a thing. And let's do... What the hell? Countdown. There we go. I'll be right back. Hello. All right, I'm tired of waiting now. There we go. Let's just go. The anticipation is real. No. Okay, where were we? All right. Yeah, I entirely switched context here for a second, so I have to get back to what we're doing here. Yeah. Okay. So it was like the error message from here got swallowed up by the function call. And oh yeah, but that's fine. But then we want to know why we're leaking. That's right. So right. And this did not help. We're still leaking. I want to check if we got the pop here. Where is this function? Run function. Yeah, we got the error, then it pops the things. Good. I'm not sure if that's what we want to do yet, but I'm just trying to see if we can deinitialize the thing. Actually, you know what? Let's not do this, actually. Because this does not... No, wait, but that should include the... This should include a call to the thing. Evaluate assignment. Hey. All right, you do that. See you later. Okay, so we evaluate assignment. The lookup fails. It bubbles up. To run function, because that's where we're running it. This is a statement that's being run inside the function's scope. And that results in an error, then we pop the frames. Okay, you know what? Let's just do this. Let's go to... Well, actually, no. We can't do it. We don't have these addresses. I'm not sure which of the stage captures are being... down here. It could be... Yeah, okay, so it's probably the run function then. Okay, so basically, could we check here then if we have an exit code? We run the function. We kind of swallow the error here, and we put it in the exit code as an error. Okay, so we kind of have like a local, right, and then a local error happening here which gets swallowed up, but then we never check the exit code. So basically, so potentially we could check here, like we could check if stage exit code or status. So okay should be false at this point. Let me just double check this. Status from term. Yeah. This is like translated to that. If status is not okay, then I think we want to do some kind of error handling here. We want to kind of like abort the pipeline or something like that. But it's still strange, because it should just get the stage, continue on its merry way here, get this handle, return the handle. It even gets traced here. No, this is just logging, I think. Yeah. And then, yeah, this gets returned as a value with run pipeline, which is called from here, which is called from run, which is called from here, and this handle gets returned. So whenever this handle gets deinitialized is when it should get cleaned up. Hang on, let me check this whole thing. To do error handling. I'll just put that there. Now nothing's really happening here with the error handling, and this is just returned, right? And then you are being called from here. No. You are being called from here. And you're being called from this one. And you're being called from here. Now this one doesn't even, this doesn't check anything either. It just bubbles up. This one returns evaluate pipeline, which ends up as this value here. We're checking if we have a function and we run it. That's all well and done. And then it just bubbles up. Whoopsie daisies. Which should be like execute expression. And then you're called from here, which is like execute statement. And you're being called from here, run statement. We're not doing anything with the inner value. We get out here at this last stage here, where we get maybe a value. If we have an error, we render it. And then return. If we have a value, we get the code, which is like, yeah. If it's only like, so it's optional. It's only like This is kind of a weird way how we're doing it, but basically we're checking if we got an exit code that is like not okay, then we return it. Or if the handle status was not okay, we return the exit code. If the exit code for some reason doesn't exist, we just do a standard 1. Okay, so then we get that code from the process handle, and then we check if we have it. Well, I guess it would never be success, but whatever, it's just a safety check. And then we return the exit code. Oh, we never deinitialize if we have that there. Okay, that makes sense. So basically we want to we want to defer this. Wait, okay. Yeah. I'm not even sure if we need main there. We could try without. Okay, there we go. So basically what's happening is that when we call the modular function, it runs these two. When it gets here, this actually fails, but since we don't have proper like error handling, it just, you know, silently fails. It gets swallowed up. The function itself gets returned, or has an exit code that is a failure, and then the program quits. So if we put something here, this shouldn't happen, or this shouldn't echo, or whatever. So we shouldn't actually echo that. Okay, good. So it fails here, except we don't get like an error message. And we could add that. Like this catches the error and does something. We could also check here, like if we get an error, well, then we are down here. And then we could do like render exit code error, and I guess we'll take this for now, but we would probably need to have the proper writer here. Exit code error, the code is the code. Render exit code error. Writer. I guess we do have these things. We don't have error, but we have an exit code. Which one is this? Interpreter or command run? No, command run and exit code, yeah. And then we say we have some execution error. We can actually show the source as well. We could do let's do, we will grab, do we have the source here? No, but we have the document. Or do we? No, we have the evaluator and then get, and then document store. And the path is gonna be span start file. That is the document. All right. Source. It's going to be document source. And then we'll create a line iterator. We could probably copy this thing. Log. Whatever, let's just copy the whole thing. Log span rider and span. So we got a span, a rider, and let's also have the source. Right, we have the span already. We don't need a document. We need the line iterator. And this is just going to be rider print. Okay. Now we need to define like the span color. And let's have like red. Right. Hello, piano. Yes, I'm 30 plus. You can also say I'm 20 plus as well, if you want to be sneaky. Right, so what's going on? What am I doing? I'm just ticking here. Yes, we got a script execution error. The error is actually now... It depends. So basically here is like if exit code, I guess we could do like a switch on exit code. If it's success, we return. If it's a byte, we will get it and do something with that. If it's an error, we will also wait, no. There. So I want to do this. Whoops. Let's just do this. And that. So if we have a byte, terminated with exit code byte, and here is like an actual error, but this is an error, but this is gonna change later into like a type that works better there. All right, so here we got the source. Now we do try log span writer span and source. Let's just do document source so we don't have to deal with this. And should we show this before? I think we show this last, so you can see the error straight up, and then you scroll up to see the source. Writer is nowhere to be found. Okay, let's change that to a writer. T works with errors too, by the way. Okay, cool. Well, I'm gonna change it later anyway. So, also, what does T do? Hello, Neurosite, by the way. Long time no see. How's it going with the library, or are you on to other projects now? With Cbor. Oh, you're 17. Okay. Render exit code error. Yeah. All right. What's happening here? You want to have a path, a span, exit code. Well, wait, the path? No, you don't need a path. We got the path. Okay, we just need a span. The span? Do we have the span? Do you have a span? No. Well, we do have the span. Oh yeah, we do have the statement span. Yeah. So, statement span. There we go. Still, you see where the most time is spent on flow. T is equivalent to tag name or error name. Oh, I didn't know that. Okay, cool. That's good to know. I should check out that sometime, like the whole documentation for formatting. I know that they recently changed it though, but so yeah. So flow was the was the editor, or well, Piano, to be honest, I've actually used Codex, which is basically, I mean, I guess it's basically a ChatGPT, but it's like a special version that kind of jump-started this project. And you can use it for like certain, like you can use it for like help and stuff, but you know, to be able to program yourself, you have to practice, of course. Flows the text editor. Oh yeah. Cool. How's it going with that project? So I guess what I'm trying to say is like you shouldn't like dismiss AI completely, but there's also a point to actually doing stuff yourself. Because if you don't, you will never learn what is actually happening. Yeah. Okay, so we don't have any more errors. I'm just double checking what's happening here. So yeah, now we should get like an error, exit error thing. There we go. Hello from module, this is my string. Yeah, so we're executing this line here, and that's where the error happens. Cool. Unknown identifier. Okay, well, this is kind of the outer context. This is the outermost context. So it doesn't really show where the error happened. We don't have a call stack trace really. So that could be something to improve on. Actually, let's add a new section here, which is like error messages or error handling, or yeah, error handling. So basically like call stack when executing functions. Call stack, yeah. Yeah, I'll just add it there. Flow's doing really well. It's getting close to being a realistic option for general daily driver use. Oh, cool. Awesome. It's so nice when you have like a project like that and you get far in it. Get that far. Yeah, debugging, very, very important. I mean, I've spent a lot of time recently on debugging tools for this project just because, you know, I would never, I mean, it would take so long to fix every little issue, and it helps a lot. So very, very important, even though it's kind of maybe a little bit boring, but I don't know. I like writing tools and stuff, so I mean, I think it's like an interesting thing. Okay, we kind of solved the issue. So what I first thought was like a bug. It was actually just that we didn't show the error message. Also, we do clean up the value properly now, so I also want to try not doing main, just initialize like this. Okay, cool, that works. So let's keep it like that, because I want to avoid deinit main as much as possible, and then see if we can maybe even remove deinit main at some point. All right. Yeah, I know I'm right. No, I'm just kidding. Okay, so what do we want to do now? Let's go to do, and let's see, modules, right, executables, yeah, this whole thing, yeah. So let's see if we can work on some of the features here. Typed pipes, yeah, there's a whole can of worms there. Oh yeah, I was thinking maybe we should start working on the semantics, because it feels like we're kind of adjacent to that right now, to be honest. And it's probably good to get it in now, because the longer we wait, if it's gonna be something that's gets like ingrained into the whole project, it's gonna be harder to get it in later, like build it on later. It's better to do it early so that we can get like the correct I guess, pattern in from the start. And yeah, so I think actually we want to start on the type checker. Now, I've been thinking about this a little bit. The type checker, I think, is going to require us to kind of build up the scopes, just as we're doing with the executor. Like, every time you bind a variable, that variable is in the scope. It has a type. You know, it's, you know, you have to know if a variable is available in a certain scope and what type it is to be able to type check, right? So we need a scope structure for the types. And then once we have like everything mapped out, we can also do type inference. And then, so I'm thinking that we want to use some kind of lazy type that will say that, oh, we don't know this yet, but we're gonna infer it at some point. And at the end, if we didn't succeed in inferring a type, then I guess we would show some kind of error there. So yeah, let's get started on this. We do, like, the thing with the type checker is like we already have a type checker. This is like the AI produced type checker, but I've honestly never really looked at this and I don't know what's going on in here. So I think I'm just gonna throw this out and do something that I built from the start, because this looks like a whole bunch of weird stuff going on here. So I just want to do this, you know. So what I want to do is, because I want to learn this stuff. So semantic symbols. Yeah, I'm just gonna throw everything out here, I think. Let's make a directory here, semantic AI, and yeah, I'll just move. Oops. Okay, good. Now, do we get any? Let's see if we get any like errors. Yes. Oh yeah, module loader is also like deprecated. You are not even used here. All right, there we go. Module loader. Who is doing that? There we go. Let's get rid of that. Okay, there we go. No one is using that anymore. Cool. Hello, damn guy codes. Piano, I started learning Python and tried to make a simple calculator. Calculator worked through the terminal. I remember spending 8 hours on a bug back then just to figure it out. I mean, that's the learning process. That's just how it is. I mean, you know, when I started out, I couldn't even try to formulate in my mind. I thought that was like the biggest hurdle when I first started learning programming. It's like, okay, I know what kind of I want to happen on the screen, but I have no idea, no clue on what kind of programming shenanigans I'm gonna have to do in order to get there. Like, there was I didn't understand what kind of tools I had at my disposal and how to use them. So you have to kind of practice that, turning what you want to happen into, you know, into these programming steps that you need to do. that took a while to actually learn. And every time there was like a new thing that I wanted to do, it was the same hurdle over and over again. But then eventually you would learn how to like generally solve an issue, basically. Does creating a bash-like lang mean you're also working on a Zig-based shell? Well, I mean, I guess it could be extended to be a shell. Right now, it's just like it's just it's just a scripting language that looks like Zig a little bit. I don't know. I'm just gonna use it as a scripting language right now. You have a lot of time. Unless you get like children early. But yeah, you should have a lot of time to learn. If you add a REPL, it's basically a shell. Yeah, I mean there is like a REPL, but it doesn't work, so I've disabled it basically. I'm gonna see, maybe it's like an afterthought. Basically, I think I'm gonna focus more on the scripting because that's my requirement, like my personal requirement. But it would be cool to have a REPL as well, for people can learn easier, I guess, with REPLs. Maybe try things out, and then it could basically be a shell, as you say there. Dumb guy codes. You guys are geniuses. So are you? I guess you code as well. What language do you use? Okay. Let's go. Wait, where are we? Semantic. Okay, let's just start with. Let's just do like a type checker here. Type checker. No, Zig. And then, okay, it would be cool to create the language in Runic then later. I'm not sure if I'm gonna do that actually, because a script is a scripting language, so it doesn't really make sense. It's gonna like lower the optimization. Yeah, it's not really, the purpose is not, it's not actually like a generic program language, so I don't think it's even possible to do it like in a good way. Yeah, I am a developer, professional developer as well. Yeah, I'm a web developer normally. But I've been programming before that as well, so it's always been a hobby for me. Okay, let's make the type checker. So what do we need? So let's make a new thing here, type checker, and I guess we'll start with like some kind of function that will type check, and we get some kind of type checker results. And we need some kind of options, I guess. Type checker options. Or we could just do self type checker. It could be a struct or like a union enum or something. I don't know. It's just I'm just trying to think a little bit top down here. Oh, so you want to be a white hat? Okay, so you're basically a polyglot in programming languages. Wow. That's a lot of stuff you're doing. That's impressive. Yeah, the more you do, like the more projects you can show when you apply for a job, I mean, the better. Because then you can actually show something that you've made, and you know they have something tangible. Because if you just get a junior from that's like released from school, you you don't know if they have previous like you don't know the power level of that developer basically. I don't know. In my experience, like the education hasn't actually been like a huge factor, but I don't know. Maybe it's like behind the scenes. You know, you get if you don't have education, you might get filtered out from the early process or something like that. But yeah, unfortunately, maybe that's how it is. I don't know. Okay. What do we do here? So basically, I want to be able to create a bunch of scopes. So we want to basically, so we have the AST. So we need the AST, which is going to be AST. Well, right now it's going to be like a script. So AST, we're going to have this. And then I mean, it's basically going to be something like this. You create the scopes. Scopes from AST. I guess this would be some kind of error as well. So we create the scopes from AST. Then we will do the actual like type check of all the scopes, I guess. Yeah, see here. See, now I'm trying to like think, because this is such a huge task. You have to kind of break it down into smaller things. But what I'm doing right here, like this could get thrown out. I'm just trying to figure out what the steps would be, high level steps. Now it would be, it could be more better to like do everything in one function or something. I don't know, but basically, or yeah, but I'm trying to think about in big steps here. So we're creating the scopes, and then we want to get some kind of we want to like materialize or populate or whatever you want to call it, infer. So populate inferred types. So we want to do something like this. And try that. And then we want to do the actual type checking. So then it's going to be like return self. I'm not sure what to call this. But yeah, like type check inner or something like that. Scopes. All right, something like this. We create the bunch of scopes from the AST. We infer the types, and then we do the actual type checking. Now I guess we'll see if we need more steps here, but those are the three main steps that I'm seeing right now. So let's make a type scope, I guess. Type checker scope. Actually, we could just put the thing in here. Scope. We can actually just put the error here. And I guess the scope here as well. Well, let's put the scope down here. I like to have the main type at the top. Alright. Okay, so what would the scope be? I guess we have a bunch of a bunch of expressions really. It's gonna be like expression wrappers maybe. Okay, and also if we go to the AST right now, it's a little bit mixed up here because the thing is like we have two different things. We have statements and expressions, and it's kind of ingrained into the whole thing. Where's the statement then? Here's the statement. So basically a script is a bunch of statements. The statements themselves can be expressions. It's just an expression in a statement. But then we have all these different things. Except this one is not really, it's not going to be here. I'm going to remove that. This one is not implemented. This is not implemented. This is not implemented. This is so basically only these two exist right now. Yeah, I'm making a type checker. It's my first time. Oh, you're studying maths and physics. Cool. Do you think is it fun? I love like watching videos about those kind of things. But I don't have time to actually. I mean, I like maths, but I don't. Yeah, I like programming more. Let's say. But it is interesting. If I need to use some kind of math concept in the programming, I have to learn it. So that's good. Anyway. Yeah, so we have these two declarations. So these three are the only ones that kind of exist right now. The rest will come later or get destroyed. So I'm only concerned with these three right now. But what about scope though? This should we should also have. It should include bindings as well. This is gonna be sort of like the scope stack, actually. This type here manages lexical bindings for the interpreter. So this is the scope stack, but it has the actual values. It's meant to hold like the actual values of the things, while this scope is meant to just hold like the types of everything. So maybe this isn't a bunch of wrappers against of all the expressions. Maybe this is just. But how would we know? So let's think about this. If we go to let's do like type checker test. Right. This is now a blank scope, right? As soon as you say this is a string here, now we have S. At this point, we have S in our string. So I think what we need to do is we need to go through each statement and do the checking line by line, basically. Almost. Or statement by statement. How would we infer, though? Okay, so the scope step might catch things like we have an unknown identifier, for example. So if you would do like a equals 5, now this is an unknown. So once we get here in the scope thing, scope checker, it would like, hey, a, you're trying to bind a to 5, but a doesn't exist. Or you're trying to assign 5 to a, but a doesn't exist. So that should be like an error there. So first we're like doing this, and then we bound S to the scope, and we know the type, if the type is a string. Okay, And then we get here and we see that a is equal to 5. Okay, but a doesn't exist, so we need to do a lookup. We need to kind of almost execute the statement. It's very, very close to what the executor is saying, like what the interpreter is doing. And I think that this step could be kind of baked into here, I think, because the lazy types could point to another lazy type, and so when that other lazy type gets like populated, it will like trickle through and populate all. So we could have like a linked list or something of lazy types that are dependent on each other or something like that. Also, thank you for the follow, Mental Equilibrist. Trying to understand what you're doing, yeah. Yeah, I'm trying to like break down this issue, like this problem, in smaller steps and understand what I actually need to do in order to implement the type checker. And I'm trying to think ahead of what problems we could get into by doing a certain approach. I don't want to just get started and do like paint myself into a corner to do the like the wrong thing. I want to think a little bit ahead so that I can have a clearer picture of what I want to do. Just a little bit. The lazy types is basically an idea, because let's say I'm assigning, so okay. When you see this statement, what type is S? It's a string, right? It's pretty obvious. And what you did there is a type inference, because S doesn't itself have a type notation. So if I now say that it's a string, then of course I have to have a string here. And now we know that S is a string, right? But if we didn't have the type notation, we have to infer the type. And how do we do that? We look at the type of the initializer, which is this one. But you could also have, like, this is pretty obvious in this case, but you could have another variable, which is a string, and then you do this. But what if this statement alone doesn't have type information, let's say, but it does have this identifier. So you need to know what B is. And how do you know that? You have to keep track of every statement and be able to look up what B is in this scope. So that means you need scopes in order to get this. Also, it's like the lazy type is basically, we can assign, it's just a convenient way to kind of wait with assigning the types until we know what the type is, I guess. I'm not sure if we're gonna need it. Maybe it turns out we can actually just implement all the types at, however, it's gonna be something like this. Like, let's say you have a function, recursive function. I'm not sure how familiar you are with this, but let's say you have a recursive function returns, I don't know, a string or something. And this calls itself. Or it returns itself. Let's say we want to infer the type that it returns. How would we know the type now? We don't, right? We don't know the return type of this one. so we don't know what it should return. Let's make this a little bit more. So I is 0. We're gonna do like echo hello. If I is less than 3, we will call this. Okay, but now we know that kind of because of how this language works, it's like when you echo something, this actually is a string that it outputs, which means that the return, so to speak, type, the standard out, is string. So now we can infer from this statement what the return type of recursive function is. But we still want to have this in the scope at this point, but we don't know the return type. Yeah. So yeah. So that's why we kind of want to have, I think we want to have like a lazy type in that case. And I'm just thinking about how they would kind of propagate to reveal what the other types. You could have a whole chain of dependencies of inferred types that will kind of propagate through, and there could be I think we're gonna have like some kind of linked list or linked tree or something like that to be able to, because you have one type could be dependent, or yeah, it could be dependent on several types actually. On several, it's like a many to many actually relationship. Because you can have, let's say you have var y equals b, and then y equals s. So now this has like two dependencies. It has this one and this one as well. Right? But then let's say that s, let's say, well, we know what b is. So that gets like resolved with what b is. So now we know that b is, but then we want to check if s is the same, right? Y is equal to s. So let's say s is 5. Well, now this is wrong here. So once this type gets, the type of this expression gets resolved, then we know the type of y, because the binding happens here. And assignment, yeah, it has to be assigned here. So now we can check this one, because now this, okay. So then we also need to store like where we need to, it's like in the moment where we have type inference available to us, we can also check the expressions where they are stored. I mean, we could either do that, or we can just do as I do it here, like we're just running through everything to infer the types, and then we do the type checking afterwards in the whole thing. Maybe that's better. Yeah, that's less complicated. Yeah. So we just have a bunch of lazy types. They will be propagated through and resolved. I guess, yeah, resolve is a much better word. Resolved. Resolve inferred types. Or resolved lazy types, I guess we can also say. I don't know if that's less descriptive, maybe. Yeah, I guess, yeah, I like it. And then we do like type check for everything. So that runs the actual type checker. So here we're kind of building what we need to be able to type check with the scopes and the types. And then we do the type checking. Something like this. Yeah. All right. So let's see. We have let's see, scopes from AST. some kind of error, and we get scope out. Okay. And then we have resolve basic types with scope. Now this one could be a pointer because we need to change whatever's in there, probably. And then whatever, let's just put the pointer and everything there. Now this one would be just a void. Okay, and then we need the type check inner. Scope. All right. Okay, now we just need to implement it. Easy peasy. Okay, so the scope. We have the AST here, so we could just, you know, we'll create a scope. And I'm just gonna do this for now, so that we can oops, there we go. Now I'll get formatting there. Okay, it's kind of annoying that you have to do that before you get formatting, but whatever. Okay, so we got the scope. Now what we want to do is we want to loop through the AST statements. I want to have this in a separate function though, because this is going to be a common pattern where we loop through a bunch of statements. So this is actually going to be, let's do like self. We probably need like an allocator as well, so let's just add that right now because I know we're gonna need it. Alright, so this is gonna be like self. Yeah, I guess we'll do like run statements. Run statements. And the statements are self AST statements. We could also add the span. So actually, you know what? I'm gonna do this. I'm gonna go to AST and we have the AST script. Now this script, you notice, has statements, a bunch of statements, and span. And then if we go to block, it has statements and span. It's the exact same. So what I'm gonna do is what someone suggested here. I forgot who it was. Sorry. But basically, we could just do this, and then we're done. And it doesn't. There's no errors there. It basically means that now we can say, well, the AST is a script, but it's actually a block. So we can say run block, I guess. Which we can now define here, because the block is like a common type that we're using for, you know, function bodies, for loop bodies, and any kind of block that you have. All right, and then we get the block. Let's say, yeah, this is a pointer, so that's fine. We don't really need it to be a pointer, but whatever. And that this would be, I guess this would be like a void, because we're getting a scope that we will modify. So we modify scope with that thing, and we'll do try, and then we return scope. So that is, I mean, that's basically the whole thing here. This is, it's nice when you do this kind of top-down programming, I think, because you get kind of like a nice structure from the start. However, it is also a kind of risky because it's not necessarily the best way to do things. Like this might get, some of the things happening in here might be better if it happened in here and vice versa, you know. But let's just keep going and see where we end up. We can always change things later. The laser types help to gives you a hint of what type it is. Because of this, you can analyze types or place order. Yes. And also scope helps you to what's the type. Yeah, the scopes, I mean, okay. If you look at Zig here, and basically you think about almost like this, like everything in a curly, everything in braces is like a scope. So if you define a variable in here, it will only be available in this scope. You cannot say, you cannot take this identifier and do stuff with it out here because this is out of the scope. Right? And this is a common programming language thing. Like every program language basically has this. Because you need to bind identifiers to values or references or functions or whatever. So in order for the program to know what we're talking about when we're saying scope here, which is unfortunate name right now because we're talking about scopes, but in order for it to know what the scope is, it needs to look at, okay, which scope am I in? I'm in this scope. Okay, where is it defined? It's defined here. You know, something like this. In reality, it's actually, you know, our scope is like a map of bindings to, like identifiers to things, and so we would just have to look up what this name is in that map, and we can get the information there. All right, so run block. What are you doing? You are going to, just loop through the statements and then we'll try run statement, self run statement on scope, and the statement is the statement, which is a pointer. So that's great, and that's basically it for block. Now there might be some kind of frames we need to deal with. I think we want to have the same kind of frames that we have in the actual execution in the scope, which means that, well, the scope isn't just a flat list of bindings, it has to be a tree. So, oh man, but that does, okay, I just realized that we can't have the exact same structure, I think, because how do we actually do that? Because in the execution, what we do is we push a frame if we want a new scope, and then when we're done with it, we pop it, which makes it basically go away and disappear because we don't need it anymore. But here it's different. Here we actually want to have it so that we can refer back to it maybe later. Or do we actually? Ah, man. Okay, this is a little bit more complicated than I first thought. Of course, that's the usual. That's my catchphrase by now. I always say like, man, this should be easy, and then it's like, yeah, this was a little bit more complicated. I try to not say it's easy. I have to learn my lesson at some point. But yeah, okay, so I'm trying to formulate my thoughts as well, like, because the problem is, once we've gone through the entire scope and built up the tree, what do we do then? How do we go through how do we go through the tree? Like this one, we could have some sort of node walker that would go ahead and go through all the lazy types. We could even maybe store a bunch of loose lazy types in here that we populate, like pointers or something, just to make it more easy for that to do that. But what about this type checker? Like, would we have to... How do we like connect the statements to the scopes? Or do we just go through each scope and just check every... No, because we need to go through every like binding, or I mean every expression and check. So do we need like, we need an AST that has type information filled in basically. And then just walk through it and just check all the types. So it's like here we're doing kind of like, here we can catch errors like unknown identifiers and stuff. And here we're checking like, yeah, cannot resolve lazy or infer type. Cannot infer type from whatever. And here we're going through the entire AST. So we might need to like create a version of the AST with types filled in, or we could build it into the AST itself as well. Like the AST could have like types built in, which like type expressions and stuff like that, that we can then fill in with the type thing. Yeah, I think we have to do something like that. Each thing needs a type, I think. Maybe. Like each expression. Maybe. Or at least a way to infer the type, I guess. Maybe we could have some, like, maybe we could have like, yeah, some expressions are like the source of truth for what type this is. And then you can do like an inference to go through each step to try and find what type it should be. For example, this if here. This if would be like what you could add like a function on all of these, which would be like resolve type. And then it would look at like the, for example, you know, the then block and the else branch. So it will use these two expressions to find out, okay, what type am I? For example. That could be one thing. I mean, then you have things like literal, of course. So I think actually, yeah, we'll just implement a function called resolve type, maybe, on the actual expression themselves. And then the type has to be some kind of... Is it a type expression? Okay, let's try. Let's just do this. Let's make a type expression. We don't really have that right now. Semantics. Let's do this. Type expression import type. Yeah, let's do something like this. I like to have, like, I know that Zig usually you can have the file as a struct, but I don't know, there's something in me that doesn't really want to define a file as a struct. I want to have it, like, you know, visible as a const type expression, you know, like this. Like, I know that you can have this file as a struct, like, and have fields, you know, whatever, on it like this. I just don't like it. I just feel like it looks weird. I would rather have this explicitly like this, because then it also has a name. Well, I guess it kind of has a name if you say, like, you can do this, but I don't know. I just like having it like this. I don't know. Alright, now we have that. Let's go back to the AST. And we'll do, instead of this, we'll do root. Alright, so now we should have the type expression. Okay. Yeah, and this will basically be like switch on self, inline else, expression, result type. There we go. Let's make it into a pointer, because that's usually how we deal with expressions. I'm not sure if this is supposed to be a pointer or where these are gonna get stored. I guess they will be stored in the AST as well. So that could be that could be something that we also store. Let's do that just in case. We'll do this here. So basically the parser will actually store the type expressions. Yeah. Actually, we have type expression here. But I didn't write this. But this is like okay. Oh yeah, you also have like name types. We have like scoped types as well. That would also be the parser's thing. Yeah, it would, yeah, okay, yeah. Like binding an identifier to a type expression, that should also work. Okay, maybe it doesn't live in semantics. Maybe it actually lives here. So let's remove this. We still want to have the root here though. Yeah, okay, sure, let's use this. Fine. And so I guess if it's lazy, it's gonna be like optional. However, it would be nice if we could kind of link them together as well, because we're gonna have like a kind of a many-to-many relationship, as I was talking about. Well, okay, let's see how far we'll get with these optionals here. Okay, this would be the signature of the resolve type function. There we go. And let's see how far we'll get. Okay, I guess we'll walk through everything here. Identifier, that doesn't have. So this is just gonna be null, because we don't know. I get, okay, well, I guess we could we could supply a type scope, or yeah, because then you could look up the thing. Do you like maths? Yes. Yo, Blue. We could supply like the scope here. Do we build up the scope while we're parsing? I'm trying to think here. Yeah, there is just I guess different approaches. I wanna kind of go through one example so that we can grab, because you know, of course, if you want to resolve an expression for an integer, it's gonna be pretty simple. You know, you know, it's just gonna be return whatever integer. Where is that? Why do we not have like an integer here? Span, primitive names, optional modifiers, error units, inline. What about literals? Huh? Or primitive, I mean primitive. Primitive. Where's the literal? Yeah, I'm trying to build my first type checker here, so bear with me a little bit. Primitive type is a union We can either do this, we can also do, let's say primitive type is just a struct that has a span, and then we also have I don't know, maybe this will be like zig representation or something. Zig type. Can you even do this? No, it doesn't need to have anything. It's just a primitive type. Yeah. And then here is then how a primitive will have like integer, float. And then string is kind of weird. I think string is basically gonna be it's gonna be like aliased to be an array of bytes. So I will probably not have string here, but boolean we should have boolean. Is there anything else? Do you know how to make speech synthesis using good old photonics? Is that another question on your internship? And I will say no on that one. Photonics? What is photonics? Text to speech. I mean, isn't AI pretty good at that nowadays? But I think Windows has like a built-in feature for that as well. Or do you mean like in a programming, like in code? You should be able, like, you should be able to call. All right, yeah, have a good one. Thanks for stopping by. Do you remember old speech software for MS-DOS and Mac? I can't say that I ever did heard anything like that. Oh, you're a piano coder. Oh, okay. I was like, it felt like we had talked before, but I didn't recognize your name. Don't want to use API. I mean, okay. So, I guess you would have to kind of interface with the sound stuff with the operating system or something like that. I don't know how to do that, so you would have to. You're on your own there, but I mean, you can, if you don't want to use an API, or I guess you mean like a library, because you are gonna have to talk with the operating system if you want to do anything at all for that. You can't talk to the sound card directly. I guess you would have to look into like what is your operating system API for making sounds. Result type, yeah, integer, literal is an integer. And the span is self.span. Sine waves can generate long beep. Yes, they can. But the question is like, how do you talk to the computer to make a sine wave? I've actually been using a programming language called Chuck for making music and well, you can make sound effects, I guess, as well. So you can look into that if you want to just learn about how sine waves can work with, like, how you can make sounds out of you know, sine waves, and what you can do with that kind of thing. But it's a little bit, I think that documentation is a little bit lacking though, but it is fun. Piano coder code in C#. Yeah. What key are you in? I'm in Zig. Z#. You know what? Let's just do this for convenience. Yeah. Now we don't need to change. We don't need to change the signature. It's like it's a universal signature. Yeah. So what I was saying is basically it's super easy for these literals to resolve the type because it's in the actual thing. But when it comes to the identifier, we don't actually know what the type is. So this will be null, or if we potentially had access to some kind of type scope here, type scope, and then you could like, you know, scope, look up, self, could be self here, self.name. So then you would potentially be able to like look up the scope, you know. And that could probably be how we want it to work actually. You can either do it here. We can also like put the logic in some other place as well if we want. But I kind of like having it here actually. It's probably very simple, usually very simple logic in here. It's just that we need this magical type and the context in which it will be executed as well. And I'm not sure if that's going to happen while we're parsing or if it's going to happen as a next step. But this could be semantic type checker scope. Or semantic scope. Actually, you know what? Let's just put that in its own thing. Whoops. Yeah, we're gonna need that. I'm gonna add allocator here as well. Actually, you know what? Do I have Chuck? Yes. Okay, I don't need to no, it's not Chuck. It's what is it? Is it CHK? Or is it just CH? I forgot. Chill? No. Man, I forgot. What is it? CK, that's right, CK. There we go. There we go. Now we're in Chuck. So you can do like do I have to have okay, this is how Chuck works, which is kind of interesting because it's kind of like pipelines here, but they call it Chuck. You're chucking in this into this and then out into this. So this basically works like the same thing. Like you have an output from here, and this one is like it can take an input and then output something, and the output is always like a floating number because we're working with like sine waves. So basically we're controlling what you know, what's it called? Magnitude? No. Amplitude? Yeah. Basically, I mean, is it the volume actually we're controlling? I don't remember. Yeah. But basically, and then you would do. I'm just gonna remove my headphones because it could get pretty high. Let's see. Oh, well, this doesn't work. Okay. Oh yeah, that's right. I need to figure. Okay, well, whatever. I'm not gonna do this right now because, but this is very interesting. That the Chuck programming language, you can play around with like how does sine waves create sound, and what kind of sound do you get. You have like for triangle oscillators, and so on. So there's a whole bunch of stuff you can do with this. I know there's other programming languages also that you can that does the kind of the same thing. But this was why I've been using just a tiny bit. And it's kind of interesting. All right. Well, it's really interesting actually, but yeah, I don't have time for all that. Okay, now what are we doing? So I think that like while we're building up the scope, we could run resolve types on the expressions with the scope in place to kind of fill in the types as we go as well in the scopes. If we go to the AST, yeah, so let's say we have a scope here. And we could do scope lookup. And of course, this would now be like scope error. Oops. Let's put the error here, I guess. This inherits the scope error. Now you should be existing. Yeah, something like that. And we go to scope and we will do a lookup function, which is like scope name, and then we get error, or we get some kind of binding thing here. Name and type expression. I guess it could be like lazy there. And we get a binding. I'll just return null for now, because we need frames as well. So frame, not sure if we need like several kinds of frames. I'm just gonna say we have one frame. It's gonna be a bunch of bindings. Let's just use standard array list here. Actually, I mean, you could also have the bindings be a map. Why do we have it as a list actually in the other one? Isn't it better to be a map actually? So it could be like a string array hash map. Let's use unmanaged maybe. And then this would be a binding. and here we have frames, but this is going to be an array list because it's going to be like a stack. I just realized something. We could do this. We could bind each expression to have a pointer to the type scope, so it would know which scope it has itself, and then we populate that while doing the type checking, and then to resolve the type we would look at our own scope. That's also something we could do. All right, Penguin, see you later. Man, there's so many approaches. Because the issue is that I'm thinking about is like, okay, we can build the scopes, but once we have the scopes, then what? Like, how do we then, you know, match the scopes with the expressions and also have inferred all the types and everything? So I think probably we could build the scopes, infer the types, and also bind each expression to a scope. It's just going to be a pointer to the scope, or the scope itself could have a list of expressions bound to it as well. Maybe that's better, because that's like centralizing it, so we know we can keep track of everything from one place. I think maybe the frame structure doesn't fit here. It fits more in the executor when we actually like have a stack. Here we should actually have more like a tree. I mean, we could also, this could be like, you know, a bunch of frames. This could be, I mean, what we could have is that we could put the bindings here instead. We put the bindings on the scope. And then this would be like children scopes or nodes, yeah, whatever, which would be scopes here, right? So then it's like, okay, well now it's a tree, because one scope can have a bunch of children, which are subscopes. They in turn could have a bunch of children who are subscopes. Now it's a tree instead. We don't need this frame structure. I'll copy the deinitializing function though. We don't need the allocator. We can do self allocator and also self children. Deinitialize. So we need to go through each one. Actually, this would be values. Actually, entries. Oh. Well, okay, let's do like binding iterator. And while binding iterator next, we get the entry, we will do entry value pointer initialize, and actually if we use the name and the, we can use the name and the key as the same thing, so we can get the name. Yeah, it's good to have. Let's store the name in the value itself. So when we deinitialize the binding, we will also deinitialize so here we'll say allocator free self name and type expression deinitialize. Not sure if we need to deinitialize the type expression, but well, I guess it's good to have a deinitialize function anyway. No, wait, but these have lists. No, okay, well, I think they do need to have the initialize function. It's just that, no, because everything here is type expression. So basically what we do is we keep track of all type expressions in a list when we allocate it in the parser. And then, or the type checker as well. And then we just go through everything and deinitialize. So everything that is a type expression, we don't really need to, but these ones, but that's a declaration. Yeah. Okay, these are actually expressions. They don't need to be worried about. So anything that's a type expression, we don't need to care about. List of struct fields. This one though, this needs to be deinitialized. Or we could just do an arena maybe. Yeah, okay. Yeah. That's going to be part of the arena. Yeah. Okay, so we don't need to worry about that. Okay. So we don't do this, but we do free the name. And that should be it here. So actually we just need the value, so we don't need this crap here. Bindings, values, binding. Also, you need to be a pointer. Yeah. All right. And then we deinitialize that for same thing here. Say children, items, child initialize. I guess we don't really need to store the allocator then, because the allocator is going to be stored in everything. So let's actually not do that. We will grab the allocator from here instead. It feels like I'm doing a lot of nothing here now, right now. Okay, frame is gone. Good. Binding is done. Just like that. I should really work on making like some kind of construct that would, like, you could easily create a structure that you try out first with like fully garbage collected things, like a parallel world where everything is garbage collected. And once you've done that, we can then build, if we want to optimize it, we can build a more optimized version that manually deinitializes everything and stuff like that. That would be kind of cool. I could just use another language, but no. It would be cool if we could build that in Zig. And I mean, you can. All right. Well, the way I'm thinking about it now is like if you have like a bunch of references, you have to still manually release them, but at least you wouldn't need to do all this manually here. Because we could have automatic, you could have an automatic function that would look at all the fields. You want to deinitialize the scope? Okay, we're looking at all the fields and trying to see, okay, what kind of deinitialization do we need to do on these things, depending on what type it is and stuff. So you could have like an automatic deinitializer, something like that. Or you could just put everything in an arena as well. Like we could put the whole thing in an arena. But I've had bad experience with like nested arenas. For some reason, nested arenas is apparently doesn't work very well. But okay, let's see if we can get ahead a little bit here, so we can actually try this out. Okay, yeah, the lookup is basically gonna be. So we're looking up in this scope. Now this scope is this is only a node in the tree now. So we're basically also, yeah, we need a parent as well. We need a parent, which is going to be a nullable optional pointer to a scope. Starts out as null. We need like an add child. Actually, we could return the pointer to the child. Oops, did I see? And basically, you know, children append. Yeah, we need allocator. Oops. Item is init, and then do try. You don't return anything, no. And then we do like children get last. But that doesn't work because it's not a pointer. Right. So we have to do like items, children, items, length, -1, address. There we go. So that's add child. And we never should remove children here. They should always be there. Okay, so now lookup can actually look at the parent to see if we have a parent. Then, so basically the root scope is the only one that shouldn't have a parent in the tree. And then add child. Oh yeah, so add child. We would get the child here, and we would say that the parent is going to be self. And then we return the child. There we go. I guess you could also do like a special init function, like init with parent or something like that. Parent is that, and then we just set parent to parent. and then you would be in it with parent, self, and then we don't need to do all this. We can just return. All right. Okay. So now, like in the lookup function, we can say, well, first we need to check if we have name in our bindings. So let's look up yeah, I guess this would be like, so basically, yeah, we could just do this. We can return bindings, get name, but this could be an error. No, it can't. Okay, but it can be null, or else we want to return, well, okay, so if we have a parent, we will grab the parent and we'll return parent lookup name. Otherwise, we'll return null. You can also do like const parent equals self parent, or else return null, and then do this. I like that also. So if it doesn't exist in this scope, we will go up the tree, up to our descendants, and see if we can find the thing in the scope. Yeah. Now it's gonna get interesting because, like in the other scope mechanism, we have things like blocking scopes, which will kind of create a barrier between two nodes. So you can't like go up but beyond the barrier, which is the used in, let's say you call a function in another scope. So that function now only has access to, I guess it wouldn't really matter in a type sense. But that function would only have access to its own closure. But it wouldn't actually matter. The only thing we're interested in that case is like, what do you use with the function return type, basically, and what do you send into the function. We don't need to worry about the closure, I don't think. The closure is like, yeah, we don't need to analyze the closure at that point. Yo, Roland. Since I removed phone number from my Twitch account, my messages in chat don't come through. What? Even from another brand new account? Okay. Yeah. That's super weird. I mean, I'm gonna guess that's how it works. Oh. Also, thank you for following me on Twitch. No, wait, that was the other one. Piano Coder. Yeah, that was Piano Coder. Yahya. Or did I already say that? I don't think so, no. Maybe I did. I don't know. Okay. Yeah, no problem. So are you watching on Twitch and chatting somewhere else? It's an anti-bot measure. Oh, okay, okay. Well, I mean, I guess it makes sense. But it's still kind of weird. They should improve their verification stuff in that case, I guess. I wonder if that happens like if you sign up with like Google or something. I'm not sure if you can actually. Maybe you have to create your own account there. I don't know. Anyway. Okay, so that's the lookup function, I think. I'm just thinking of... I think this is a lot simpler than the execution scope. The type scope seems to be a lot more simple. But I guess we'll find out like what kind of errors we're gonna get. Okay, so we have the mechanism of having a scope tree, adding bindings to it. The tree, children, parent. Lookup will look up, and we're going up the parents. We can add childs, we can initialize. We should also be able to declare. So let's add a declare function. And we have some kind of name. Now, this is going to get interesting because we have a name and then we have a type expression. I'm just thinking of what we need. Okay, well, I guess we'll just go with it and we'll see where we end up because, yeah, we're just gonna have to wing it here. Yeah, and this would just declare it in the current scope. So basically, just bindings, append, or put. And this is where you can get an issue. This where you can get here. You can get like we shouldn't actually get the issue because the parser. No wait, the parser doesn't check the scope double bindings. Yeah, I guess the semantics here would be if we get double. So here this would be double declaration or something, multiple declaration. Or identifier already declared or something like that in the scope. So let's do like put, or let's do like get or put. It happened to me before, like a year before, 4 to 5 months later, created a new account, it got fixed. Okay. Strange. How is the support ticket system? Now that you have like experience, maybe. Unused. Okay, well. So let's get the entry here. So get or put will on a hash map will either get or put. What you get out is the entry. So you always get the entry out, and then you can check whether or not we actually got a thing. So if it found existing, you can look at this one. This will be true if there was already an entry there, and false if you created a new entry. So basically we can say if we found existing, we can now, you know, report some kind of error here. So we can say error identifier already declared. And then we can also, you know, we have the information about the actual existing one. So we can also give information about maybe where the existing thing was. Because we could get the binding and we can get the type expression and the span if we have it, I guess. For example. So, but then let's see. If we then didn't find it, we just say that the value pointer is going to be I think we're gonna dupe the name, perhaps. Not sure where the name comes from. The name should be stored in like the expression. And the type, yeah, it should have the same life cycle, to be honest. So let's just use the name actually. And then we don't actually need this here. We don't need this. Well, no, yeah, we don't need this here. I mean, we could have it for safety, I guess, if this gets invalidated, but nah. We do need to deinitialize the actual list here, though. Okay. So now you will be... Hang on, I need to charge my headphones. Alright, so you will be... Yeah, type expression. Right? No, binding. Right. Oh yeah. Name and type expression. There we go. Yep. Cool. All right. Okay, so we have a basic scope structure here now. We'll see if we need to like augment this later with stuff. Yeah, now potentially when we can call this result type, this would look up the type expression here. Yeah. Awesome. Okay, so let's continue here now. We have the AST. Maybe we should like store the scope as well. Well, I guess we'll figure it out. We have the AST there. Yes. Do you have like an arena or? Now it's part of the parser. I wonder how we're gonna create the new the new type expression types though. Let's just I guess I could just add an arena here, to be honest. Let's just, yeah, okay. Let's just make an arena. You just have to make sure that... Oh, it's heap. We just have to make sure that that we don't like have nested arenas. So we need allocator and then the AST. I guess technically we don't really need AST. We can like have the AST here as well. But whatever. This would be, yeah, the AST. And then arena is going to be initialize with allocator. There we go. And then we have deinitialize, allocator. No, we don't need allocator. We just need self type checker and self arena deinitialize. There we go. And that's it. Red says Twitch doesn't address this issue at all. Look at this YouTube cake. Okay. Good customer service. Yeah, I mean, yeah, I think it's like when you have, I personally, I understand, like, I hate reaching out and getting like to going through support systems. It's so, I just hate it. It's like, it should have worked in the first place, man. No, I understand why and everything. It's just annoying to have to go through, especially when it's super bad system. So we don't know then. We don't know if the customer service on Twitch is bad or not. I guess I'm assuming. Well, I shouldn't assume anything. Okay. Why is the AST script? Oh, it's because they have the same name. Okay, let's just call this the script then, I guess. There we go. Okay, so now if we then say, let's also add like an allocator function. No, that's not actually. Let's not. Let's do type check, scopes from AST, run block, run statement, scope initialize. I mean, okay. Do we need to store the scopes, like, or can we just like deinitialize? Alright, let's say the result is just a message and it has the information needed. We are like detaching some kind of information there. We can deinitialize the scopes here. Fine. And I don't want to have to solve these kind of issues before I actually solve the algorithm itself. Yeah, it is kind of like does introduce friction when trying to you know, solve an issue, like trying to make something this like more complex, like figuring out, okay, where should I deinitialize, how should I do this, you know, should I need to detach this from the memory here, should I need to move it, whatever. Like, I just want to do the stupidest thing first, find a good algorithm, and then optimize for that. That's why I was talking about before, where if I had like some kind of stupid automatic garbage collection you know, thing that would like automatically go and deinitialize everything. I mean, I guess this is the arena, so we can use that. That's fine. But we still need to... Well, actually, we don't need to do this because we're doing it from the arena. What am I doing? Okay. Anyway, let's just keep on doing it. Yeah, no problem, Roland. It's no problem. It's me, I'm distracting myself. No, but it's like, we should be able to talk to each other, you know? Sound like a therapist or something. Let's see. Run statement. We need the current scope that we're running in, And then we need a statement, which is the statement. And we do that. Okay, and then we switch on the statement. And now we have like function declaration. We have binding declaration. And then we also have expression statement. And let's do pointers just in case we need it. Okay. So for example, we have, let's do binding because that's probably the easiest one. Let's do like, I'm not sure what to call this, like evaluate is, sounds wrong because we're not in the interpreter. We're not in the evaluator. We're in the type checker. What we're doing right now is we are, I guess we're just building the scope. Okay, let's just call this run binding declaration. Keep on with the thing here, and we have the scope, and we have the binding declaration. So this is like an exact copy of the interpreter, almost, not really, but with different context and everything. But basically the structure and everything is exactly the same. Binding declaration. All right. So, scope, declare, name is binding pattern Okay, yeah, it kind of depends. If we didn't bind it, if we discard it, we don't really care about the type because it's not going to exist anyway. These two are not supported, so I'm going to return like an error thing here. So we're basically going to do a switch on binding pattern. Wait, yeah, you're a pointer. And then we're going to do so either we have like identifier or we have discard. Discard basically we don't do anything actually. Yeah, we don't have anything there. But then we have like what was it? Tuple. Tuple and record. This will return binding pattern not supported. So this was the only one that we used to declare, and we get the identifier dot name, and the type is going to be expression initializer, which is an expression, and then resolve type And then we need to pass in the scope, right? But there's an issue here, actually. I just realized. What if the expression, can the expression come from some other scope? If you have like an identifier that is defined in another scope, well, it should be available in this scope, I guess. It should be like in a parent scope. Yeah. All right, that should be good, I think. Okay. So we do that. We do, I guess, try. There we go. Now, what do we have? Function declaration. All right. Run function declaration. So same thing here. I'm gonna copy this. Function declaration. Now this should always have an identifier or a name. Yeah. Badly named identifier field. So this should always be like scope declare self allocator. No. Function declaration name type expression though. Well, that's gonna be a function, right? So I guess first we'll try to kind of resolve this type from this one. Maybe. And that could end up in a lazy type, like we don't know the type yet. I think it would be cool if we could do this, and then we could, like, the lazy types have kind of like a network of dependencies. And then if you resolve one lazy type, it would automatically resolve the other ones. Yeah. As I've said now 5,000 times. Okay, but function declaration does not have resolve type. Function. So actually need with scope as well. You don't use the scope, but we should still get it. It's part of the signature of the. Actually, you need scope. The interface. All right. And this as well. Yeah, they all need to have the exact same type. Okay, so here we're gonna do I guess it's like a function. Parameters. Ooh. We need a way to create the type expressions now. Or store. Yeah, we need a way to allocate them. Yeah. Okay, I'll just be 1 second here. All right. Okay. Now the issue here is that the parser has its own arena, and it's using it to store some of these expressions. I guess it wouldn't matter as long as we're allocating with an arena. As long as all the arenas are digitalized, it doesn't really matter, because we don't go into the individual pointers to allocate free them. So we would need the allocator. Yeah, we need an allocator here. And the idea is that this would be an arena allocator. So this would be the full signature now for these functions. We're passing allocator as well. Okay, because here we need to create this list, so we need to create like params types, allocate a list of type expressions. They don't really need to be pointers, I guess. Actually, yeah, no, they should be pointers. Actually, they should be these, yeah. And then n will be self params length. And of course, we need to try. Alright, so we got those. We can put them here. But we also need to populate them, so let's get the parent type here. And then parent type. Let's also get the index. Well, actually, you know what? Let's use the zipper. So this would be like self params. Now, since they are the same length, you can do this, and you can get both items out at the same time. So this would be the param, and this would be param.result type allocator scope. Let's put this in a string there. Parameter needs result type. Where we just return type annotation. So that's already done. Great. And I mean, the result type doesn't necessarily resolve into a type. It could resolve into the lazy thing. So we would have to figure out how we would map that later. But let's just figure this out for now. Maybe we should do that now, actually. Maybe we should. because then we will get like more of the whole picture. Because I don't want to have to create this, go through everything, do a small change, go through everything again, maybe even refactor the whole thing, like rip it out, you know, building it up and up. It's better to implement like a working structure that has all the features you need, and then you can like go ahead and extend it to all different areas. And doing like small iterations as I'm doing here. Okay, the return type is simply gonna be return type. So that might exist, it might not exist. And the span, of course, is self.span. Okay, now these ones, all type expressions need to be optional, but that is like, this is gonna change into a lazy type. Actually, let's do that right now. We'll do lazy. So this would be an unresolved type that depends on other types and should get resolved when those are resolved. So we would need like a doubly linked list, but it's like a many-to-many also relationship. And it feels, if we're gonna have the linked list, there's gonna be a lot of double information. How can we solve that otherwise? I guess we could have an index of all the lazy types that needs to be resolved, like in the scope or something. And then have a list there. Because so there will be so many lists of these lazy types. I guess when they are resolved, we could initialize the actual lazy type itself. But it's all going to be under an arena, so it doesn't really matter that much. I'm just thinking a little bit of the optimization here. It's okay, it is premature optimization. I'm just thinking like this could potentially be like a huge optimization issue. Well, if you have like a large file, we'll see. And that's also why you might want to use like an arena for this. Okay, let's see. Let's do the lazy type. All right. Now the lazy type is gonna have dependencies, which should be like a list. No, let's make it into an array list. And the type that we have is actually gonna be like a pointer to a type expression. Because we're gonna need to. No, actually, okay. The dependencies is just a pointer. No, it doesn't. It doesn't need to be a pointer of a pointer. Sorry. Dependencies, and then we have dependents or whatever. I'm not sure what to call it. Dependees. Dependents. Dependees. I don't know. And that's also array list, which is all of the things that depend on this type. So when we resolve this type, which is okay. I just realized that's like a bad name now. Let's call it like materialize type. So we have a little bit of distinction here. Materialize type, and the thing that this will do is basically, okay, now we know which type this should be. So all of the dependees can now be resolved from this type. So they would basically be provided, you would basically have like a function. You could have different kinds of lazy types, I guess. Potentially we could have a union enum here, but basically well, you could have like a resolver, which is a lazy type resolver, which could be, well, let's just call it resolver and define it here. This could be a union enum. So if you for some reason need different algorithms for determining the type depending on the type that you get, let's say you want like I don't know, element of, which would depend on a type which is an array potentially, and this is the element of that array or something like that. So this would enable us to do things like that. I'm not sure if we need that right now. I'm just saying that we could do that if we need to. I'm just gonna do like materialize type. This would give us a type expression that this is gonna be. So we could say now this could have a type expression, okay, which is set to null. But then when we materialize this, we get the type expression that we're materializing into. And we're gonna say also we need self lazy type. Actually, these are lazy types and not type expressions. I just realized. Yeah. All right. So now also we do want to have resolve type, because resolve type will actually try to resolve this into some kind of type. Yeah. So, but yeah, this would return self type expression. And then this would be lazy type. Yeah. Well, we need this one. There we go. We don't need an allocator. We don't need the scope. We just need to return self type expression. Materialize type will do yeah, self type expression equals to type expression. So now this one is actually materialized. And then we want to go through all of the dependees and materialize them as well. So this is like a chain reaction here. And then, yeah, I mean, I guess this would be like type expression, except like the material, like this could be depending on the resolver. Like if we want to have different resolvers, we could add, as I showed before, like resolver, and the resolver is a union enum. So, but then we also have a function here which is like material, or materializer maybe is a better word now because we're using that kind of lingo here. Materialize, and self is this. No, as lazy type. I guess we can have self lazy type, and then the type expression of the kind of dependent thing that you have, and this would like return, this would be a type expression. Also, we probably need things like allocator and stuff in here as well. And the scope maybe even, not sure. But this would like, and then you would like switch on self. Oh wait, we do need. So this is the lazy type, right? This is the dependency. No, wait. This is no. This is dependee, and then self is materializer. All right, so then we switch on self, and this, it could be anything, and then we get like materializer here, and we say m.materialize, and we just say the same thing here, dependee, allocator, type expression. Yeah, so now we can have like a bunch of different ways to do it, and as I said, like you can have like same. I'm not sure what to call it, but basically this would be just, you know, materialize and self would be this, and we don't need the allocator, we don't, well, we do need dependee. Wait, do we need a dependee actually? No, we don't. We just need to return a type expression. Okay, but this one just returns the actual type expression. So that is like the most basic resolver, I guess, or materializer here. So we'll just return the actual thing there. I don't think we ever need this. Let's just remove that. Okay. And at this point, this should be materialized, so we should have it. Otherwise, there's no point in calling this function here. We're not materializing into an optional type expression. We should materialize into actual type expression. Right, there we go. And you need that. And dependees is on self. And then dependee materialize type expression. So actually this materializes this, but this would, now we can use resolver or materializer dot materialize, and we actually need allocator as well, and we have type expression. Right, so now we're like, depending on the materializer, we can materialize this into different types depending on whatever. I don't know, but maybe we don't need it, you know, maybe yeah, I don't know. Okay, yeah, because it could be like let's say you're you have an expression which is like an array element accessor, and what you need to do is, and then you assign, like let's say you're assigning, you know, element to array 0, and we don't know the type of the array, let's say, so it's like lazy, and the type of this expression depends on the array, right? It depends on the array. So once we know the type of the array, we can go ahead and do this expression, which then would be this. So this one would have like a same materializer on this expression here, but this expression would have like element of materializer from this array, because it needs to take the array type and make it into the element of the array, and that would be the type of this expression, probably. Yeah. Or I mean, it could also be that we just call resolve type on the array element accessor expression, which would then just need the array expression. Man, I don't know, man. let's just keep going with this. We'll see. It feels like we're building two different systems right now that's supposed to work together somehow. But I do think we need this lazy type stuff. I'm just not sure exactly how this is all gonna work, but let's just do this for now. We'll have the support right now and we'll extend it if we need it. If it fails, we'll do this. This should actually be some kind of error. I think it's gonna be like an allocator error. So let's just do infer for now. And then no, let's do this allocator error. And this one is materialized. This should actually be a try now, and this is also a try. All right. So now materialize should be a thing, and you, and we return. Dependee we don't have. Allocator we need to have here. You are unused. Yeah, that makes sense. You are unused as well. And that is unused. There we go. Okay. Interesting. I think if we get a question, yeah, we should still, like, result type should still have this here, I think. But now let's say we don't find, for example, the identifier or the type annotation here. We don't find the type annotation. Actually, you know what? If this is not there, we should actually not store it as an optional. We should make a lazy type, maybe, instead, in the parser, and then connect the dependencies there. I think. I'm not entirely sure. You know what? Let's look at I don't want to cheat, but I'm just curious. I'm gonna look at the zig AST. I'm pretty sure we have like, no, we have zig somewhere. Do we have some kind of type thing? Node data tag root. Interesting. test, global, local, global, what? What the hell is this? Local var, simple var. So that's the tag. Okay, well, what about data? Node and node, op node and op node. Very, very generic here. Extra in extra? What is extra? Extra data. Okay. Just a bunch of indices. So it's like, I think it's like how it works is like they have like tables that they populate, and then the nodes themselves would just refer to the index of those tables. So to get the actual data, you would have to do a lookup there, and these are just numbers, yeah. But where are the actual, like, what's the actual data? From token, from optional, unwrap. Unwrap, we just get an index. Oh, I see, unwrap optional, I see. Token offset. It's also kind of interesting to see how they did it here. This is obviously a lot more optimized and mature and robust and just better. Of course. I mean, that's just how it is. Obviously. So we got, but where is the actual like data or whatever? Span a start and a main. See, everything is like just numbers here. Line, column, line, start, line, end. So that sounds like a span, right? I don't know. And these, I guess, points to locations, and then this points to like a file or something. I don't know. I'm just guessing here. We have two different modes, zig or zon. Oh. Parse. Yeah, tokenize, and then the parser. Okay, we can actually look at the main, like, major way they are looking at this. So parsing just parses everything, and then we get this AST with a bunch of tokens. Scratch. Source. I guess this is for one file only. Maybe. actually render. Because what I'm looking for is like the type information. I'm not sure if it's even in here. Render the tree. Expression. Identifier. Where's the declaration? Members. Oh, that's the zone. Container field. Render member. Function declaration. Modifier stuff. Proto. What is this? There's a lot of weird stuff I didn't know about here. Render expression, proto, space. Body node, render token, discard all params, write all trap. Okay. Interesting. Hang on. Let's look at, well, member, render member. What about like a declaration? Function, yeah, function declaration. Function proto. Global, local, simple, aligned. Render var declaration. Okay, let me get out of here. There we go. I got lost. It's very, very interesting, but yeah. I feel like it doesn't really help me with what I'm doing here because it's so different as well. I mean, yeah, there's probably somewhere we could look at the things, but yeah, right now, let me just try something here. I'm just thinking about this, like, should we, like, when we parse, initialize this into a type expression, and can we do it instead of having an optional there? So let's do like parse parameter. No, we don't even have parameters. Actually, we don't even have parameters right now. So I'm just going to ignore this until we have this solved. Okay. This doesn't really have a type. I mean, I guess the type would be like the type of initializer or the annotation type. Okay. We'll just use inline else here. Okay, so what kind of, like, it would be like binding, because the annotation is not actually, it might not be there, and the expression also might not have a type. So should we then say that the annotation actually has a lazy type that depends on this expression? So now we can go to parser and we can go to parse bind. No, not pattern. Or wait. Parse binding. Yeah, here we go. So the annotation is parsed here. Also, we don't have a type parser yet, so we need to create that as well. But yeah, let's say we get the type expression here. If we don't get it, we need to then create a dependency onto expression. Or do we actually? I mean, we could just use the expression directly. We actually don't really need this at this point. No, okay. This resolve function will like suffice, I guess. So yeah. All right, what else can we say here? Expression. So the expression statement, let's add and then the identifier. Let's do something like maybe assignment. This has a result type. Return expression result type. I mean, I guess that's it, because when the expression gets its type resolved or materialized, then colon resolve type on this will automatically have been solved. However, we're not really then checking maybe if the identifier, yeah, the type checking would then have to say, okay, well, let's find out what the type of identifier is, and if the expression type matches that type, and that's where the type checking would go in and do stuff. But to get the type of this assignment expression, we would have to do this here. Yeah, that sounds reasonable. So which one could we use that would... Maybe we should just go with this. We should just go with this for now and just see how far we'll get with this one. The expression, run expression, I guess. And of course this is just gonna be like no, not return, just try run expression statement expression with the scope. Here we have a whole bunch of switching to do. Okay. I mean, okay, we can also do this. We can do whoops. God damn it. Oh shit. Now that messed up the whole thing. I'm trying to do, I mean, you can kind of see what I'm trying to do here, I hope. I'm trying to do a macro. No. And then you scope why does it do that? God damn it. Okay, one more time. Okay, yank into the end instead. Path. Self run. So it's like here, when you go back, go forward. No. Do that. I'm not sure when it gets messed up. Okay, there we go. Boom. But then if we have like function literal, I'm just gonna fix these up here. Round block is the only one we had. Okay, cool. Now we should get a whole bunch of not found. If we actually run this. Yeah, if we actually were to execute this, I guess, function, we would see a whole bunch of errors in here. Is there like... No. Oops. Okay, that might have messed things up there. Also, I need to do this in the opposite. Now, why is it disappearing? God damn it. Do this. No. Okay. There we go. Can I do this for everything now? No, because it will do it in the other way. Well, I guess I can. But it will be reverse order. God damn it. Okay, whatever. Block we already have. Alright. All things called something expression. Except for those. Okay. The type though. I guess we can kind of macro that as well. Also, I'm doing like the opposite of what I said earlier, where you want to implement like a small, like a subset of the things. Also, we don't really have a wait async. I'm just gonna delete that. Function literals, no. Where's that async await literals? Match. Try catch. Import we don't have unary. Unsupported expression. Call? What? Range. Map. We don't have path. Okay, I think these are the ones we have right now. Hello VV Development. I'm coding a new scripting, Bash-like scripting language for me, for personal use only. Now, anyone can use it, but I mean, it's like a toy language, so I'm not sure if anyone would. Right now I'm doing the type checker, which I've never done before, so it's interesting experience. Let's see. What are we doing here? Oh yeah, so let's remove these ones that we don't have. Unary. Index. What the hell is this? Oh, that's the array access maybe. Well, let's remove that. Call map path. Try catch. Yeah, there we go. Thank you. Are you a developer as well? I see you're in your name, maybe. Okay, binary, ASP binary expression, member expression, pipeline, range. I guess we can do this. Oops. And Okay. Now we have a bunch of unused parameter stuff, but all of these now have a function. Cool. I guess we'll do them like one by one or something. We have identifier. So this is kind of weird, like the identifier doesn't really, it doesn't do anything with the scope, I guess. It just, you know, it just has a type and a name, but it's not a binding, so this shouldn't really do anything. I guess this just returns. Same with the literals. And I guess these, well, I guess we'll keep them in functions right now. Import expression. This does not have a binding either, so I think, but it will create a scope for the module. Unless we already imported it, I guess. Huh. This is interesting. So maybe we actually need like one scope per module. Yeah, because the modules are self-contained. There's no like external scope that gets used, that gets like available like type-wise in a module, or even execution-wise. Like the only thing that gets I guess transferred would be the environment variables. But that's more for execution and not for well, okay, well, one thing that actually does get put in there, I guess, would be like the parameters, but that would be available from the start. Or yeah, okay, maybe if you call a function with something that will kind of change what the type is, like let's say we have a variadic function, right, and we call it with one parameter. Now if we're kind of keeping track of the array length in the type, that would change the type itself of the variadic arguments. But that sounds too fancy. Okay, so how should we do the modules? I mean, this seems like a hard thing here. I'm just gonna ignore this for now. This is just gonna be like unsupported for now. I'm gonna wait with this one, and we're gonna do like to do implement, you know, module type scopes. But I think it's basically gonna be like, it's just gonna be an isolated scope, and then we're gonna have a map of scopes where the key is the file name. And so yeah, we would also prevent like, you know, potentially circular dependencies, because we would basically we could declare the function as like a lazy thing or initializing or something. Yeah, but we'll see. Let's do that though. Now assignment is interesting, but the assignment is not a declaration, so basically we're only interested in declarations here. Assignments doesn't really do anything unless we do type, what is it called, like I forget what it's called. It's in TypeScript. It's very prevalent in TypeScript. It's when you have a type that is like vague at first. In TypeScript you have a type called unknown, for example, but then you can have a function that would take an unknown argument, return a bool. So basically, let's do this. Let's do like TypeScript. So basically, let's say you have like a is unknown, right? So a is unknown, but then you have a function. I'm just gonna use this syntax here. You have a function that takes unknown. Now we can shadow here, and then it will say a is string, or wait, is string a type? Yes, I think so. Or is it? I forget. Let's just say it's a number. Okay, and then it's gonna be like if. So basically, if type of a equals a number, you can even do this. Now in this scope, in this if scope, in the if body, we know that a is a number. You can see here now a is a number. I don't know what this feature is called, but it's basically reduce. I guess it's kind of like type reducing. You're reducing the type from a very vague type. Unknown is basically, it can be anything. But then you can, if you do these checks, you know that it's a number, right? And the reason why it's like important in TypeScript is, there's no static typing on some of the data, so you have to do these runtime checks, and then it's very, very helpful to actually interpret it now as a number instead. And here you can actually do like return true. I mean, we could just return this, to be honest. But this is how you would create this. So basically now, if, oh yeah, we need like is number. If is number a, in here now a, oh, it's unknown. What? Wait. Why? Oh, right. You need a colon here in TypeScript. Okay, there we go. Now a is a number. Okay, but in the else, what is a? A is still unknown, right? So this is a really cool feature. I really like this feature. But it doesn't quite work like that. Like in Zig, for example, everything is like static typed, and everything is, you cannot do that really in Zig. But I really like this feature. But it's like, I'm not sure if we're gonna have this feature in Runic. I mean, it might fit actually because of the way Runic will work with other programs. That you might get, you get a random, array of string or array of bytes from an execution. Yo, Penguin, welcome back. That was quick. So there might be room for this feature in the design space of this language, if you want to put it in a fancy code of words. But yeah, it's gonna be yeah, that's a whole other can of worms, I think. So basically what I'm saying is that even though this doesn't declare anything, it might, do some changes to the type system, to the type scope, that will be, available after this has been ran. So yeah. Now, assignment. Do we do like existence of stuff here? We could do like we could check for existence of this assignment. Same here. We could check for existence of the identifier. Actually, yeah. Why don't we do that? So let's get the scope and the identifier, and then we do like scope lookup identifier name, and if we get it, if we don't get it, it's a null. If something goes wrong, there's an error, so we should do a try. So let's do like if try equals null, then this is an error. So this would be like error identifier not declared or not found or something like that. Unsupported expression identified as well. Unsupported expression. There we go. All right. Yeah. Yeah. That works. Literals. I guess it could depend on the literal. What do we have? Null, bool, float. No, it doesn't depend. Well, actually, yes, it does. The string literal has segments which can be expressions. Okay. So this one we actually do need to worry about. So switch on literal. And if it's a, I guess, no, null. If it's a string, no, yes, if it's a string. If it's something else, we don't care actually. If it's a string, we will say, I guess we could do like run string literal or something like that. Because it could show up maybe in other places, not sure. Scope string literal. Also, why are they public? They shouldn't be. Okay, whatever. Run string literal. Okay, so here we'll just go through all the string literal segments. String literal segments, and we get a segment. I'll just keep everything as pointers, why not? And then I mean, I guess we just do run string segment, literal segments. And we switch on the segment. Now this could be Wait. Text or interpolation? So text, we don't care. Interpolation, we will. So interpolation is, and it's just an expression. So we will just run expression. No, not statement. There we go. Okay. Assignment. Yeah, so this one would be, we have to check if the identifier exists. So we could do like run identifier. What else could we do? I think expression probably. Yeah, of course. Run expression. Could be a whole bunch of different things going on here. Okay. What else do we need? Array. Okay. This one would be pretty easy, I think, because we get an expression out, and we could just do run expression on this expression, and there we go. That's it. The range, and then later, like when we do this, the array expressions has to be the same type in order for us to kind of be able to resolve the array type. I think I'm gonna have to. I'm going to like. Yeah, I'm not gonna allow different types in the array. It has to be all the same type. Okay. The range has two expressions, so there's gonna be like an expression. Range start, and then it's like if range end, we run that as well. Pipeline has what? Stages. Holy crazy shoot. Stages. Right. Pipeline stage. Just copying for naming. Oh, come on. Stage. Stage has a payload, which can be an expression or a command. So I guess we will switch on the payload. If an expression, we will do run expression. I have a feeling that it's not great right now with this system, but I guess we'll see where we end up. Otherwise, it could be a command, I believe. yeah, command. Run command invocation, and you have like, so okay, commands right now actually are like, they are always the same thing. So it's, yeah, the type is basically, it's gonna be a process handle. So yeah, right now we don't have different types, but we are going to have different types on the commands, like for standard in, standard out, and Xcode. They are going to potentially, and also I guess the arguments as well. Right now everything like this command is like, we are, well, I guess the command is like an, you know, external executable. Unless it's a runic file, it will have, you know, variadic function arguments, which all are strings, and then we have like environment variables, standard in, standard out as strings. Actually, what we could do is, we have like things in here. Not sure why this will be an expression. But yeah, we have like, where is that? The arguments can put, yeah, they are like string literals. So yeah, this will be like the argument. Let's do like run expression there. Oh, it's a command part. Oh, okay. So run command part, I guess. Command part, or just part. Command part. Switch part. Expression. And then command part. Since we already have this now, we could just say command part scope command dot name. That's an expression. What do we have? We have word and string. Oops. So word is, I think, just a string, to be honest. Not exactly sure. Yeah, it's just a text, so we don't care about this. The literal though, we have a function. Run string literal. There we go. All right. And here we would probably do, actually I'm not sure actually what's gonna happen here, but we'll see. Alright, so we still have a bunch of stuff left. Let's do member. Okay, member. So we have like the object, yes. And I have no idea what I'm doing is gonna work here. I'm just gonna try this out. Okay, that's the object. That's the access C. And here's the accessor. Run identifier. Actually, this identifier is different now. Okay, this is where we need another scope. Because now we should be in the scope of this member. So we have to then be able to know the type of this object actually. Yeah. But the thing is, but now we don't know. I mean, this could be optional. I guess we'll just, like, if it's null, we're just gonna return some kind of error here. Member object type undefined or something. Right. Okay. So then, but then we get the type here. So now we have the type, and we run identifier. Now we need to run this identifier in a separate scope. So I guess, how would this work? I guess we'll switch on this and see if it's a scope. Wait, no, it's okay. I was thinking about the values. This is a type expression. We should have like a module here or something. I mean, I guess it's a struct actually. The module is a struct. Well, it's actually a function. Man, this is where it becomes confusing. It's kind of like a function with it's like a function with fields and declarations. It's a function struct. It's a funky struct. Okay. For now, I'm actually gonna treat them as structs so that we can get this rolling here. But yeah, so modules imports will be resolved into a struct type. Actually, we don't even know how to resolve it right now. Yeah, okay, so this won't really work right now. I guess the other thing we could do is we could do like process handles. We do have those, but they are also kind of like structs actually. Yeah, actually they are just structs. But kind of like built-in struct types. Okay, but basically the idea here is that we would look at all the different types here, and depending on the type, we're gonna see that, okay, well, you're trying to access a member on an identifier, for example. Wait, how is that a type? An identifier is not a type. Oh wait, it's a type identifier. Okay, yeah. But that doesn't really resolve the actual type. That's just an identifier. So we'd have to do like a lookup of that in the scope. I guess this doesn't really make sense. Member access on not supported. On let's do like unresolved type literal or something like that. If the type is optional and we're trying to access it, that should be like an error actually. You have to like unwrap it first. We don't really have that, so member access on optional. Promise. Okay, I'm just gonna say member access. So unsupported member access right now. Array. Yeah. We'll just do it for everything here. Tuple, function, integer, float, boolean. Now, if it's lazy, what happens then? I don't know. I guess we'd have to like set up like a check later. So basically, as you can see here, you can't actually do a member access right now. I might try to support the struct type because that's yeah, we'll see. Yo Penguin, hello Polaris, welcome back. I'll probably have to go here soon. I've been yeah, let's just do the rest of this, and then we'll try. We'll do a test run to see how far we'll get here. Okay, so the binary has, you know, left, right, and operator. Yeah, here you can do all sorts of checks, I guess. All right, so let's do like run expression on left and on right, and then we also want to get like the left type, and the right type. Oh, sorry. Right. Forgot to put a smile at face the end of the comment. Sorry. There we go. Okay, we get the two types. Now we can do semantic checks here because we only allow, well, we do allow like float, integer into float coercion, but we we don't allow string concatenation. Yeah, there's a whole bunch to do here. Implement all kinds of semantic checks here. We might have some kind of interface also where you have like a binary operator that could like generically do this or something like that. But yeah, we'll just do this for now. Yo, Pudotta Pommen, what's up? Okay, so we got if and for. Now these have like should have like scopes and stuff. So let's check. Let's just do the condition, and then we have like run block on the then. However, we need this to be its own scope, so we should do add child then scope. Okay. And then we also do the else. Actually, this would be like recursive, so this would be run else branch. Which is optional, so we have to do an if. We have if expression else branch, we get an else branch, and we run that like this. There we go. And the else branch has an if expression, so here we do run self run if expression. There we go. And then it also has a block, so we have to do that as well. So we do like else scope on the block. There we go. Actually, we should do that first, maybe. Oh man, this is gonna get weird, the order of operations here. I guess it doesn't matter that much. We could gather all, I think this also works, like we could gather all the errors in a list and produce everything, because here we don't really need to abort the operation if something goes wrong. So really all these tries are kind of weird. We should probably just store where the error happened in like the span or the expression itself into a list of errors. Actually, you know what, there's an easy way to do that. We can do defer, but then there could be a sub error as well, sub expression error. No, I don't know, we'll see. Okay, so that's the if. Now we also have the for. Where are you? Here. This is the last one, I think. So the for expression has a bunch of sources. So I guess we'll just loop through those. And we'll do self from expression. Now this is also interesting, actually, because these sources, the types of these sources determine the type of the captures. These are just a bunch of bindings, but we need these also to declare new things in the scope of the for thing. So we'll loop through, actually, you know what, let's loop through them here, because they have to be the same number here. We're just gonna assume that they're the same number. Or maybe we can, actually, we can assert that. We can say if for expression sources length is not equal to for expression capture length or bindings length, then we have an error. So then we have for sources and bindings need to be the same length. How long could this could an error be actually? For input is not captured. Yeah, okay. That's the error message that we're gonna get. No, that's not. That's another error message. Or it is an error message. Interesting that it puts it on the dot here. Yeah, so this would be the binding pattern. Do we have run binding? We have run binding declaration. This is like checking the thing here, the pattern. Let's actually copy this. Call this binding pattern, but then this is the pattern, binding pattern, and you can see here that what the type we get is from the declaration. So I would actually get the type expression from here instead, which would we put here. Okay. So now we don't need, now it's more generic. So now we can say from here, we can say try self run binding pattern, and then we need like scope, and then the pattern is binding declarations pattern, and then the other thing is this, and yeah. So now we can reuse that over yonder, here, not somewhere. Yes, so we can do run binding pattern, which will then bind the pattern to the scope. But we need a scope as well. We need a new scope. So this would be the for scope is scope add child try. So now we get a new scope that we can use for this. So we're binding a new thing into there, and the type expression needs to be source resolve type and this, I mean, it can't refer to other things in the capture, I don't think, so we can just use the normal scope here, so we skip a little bit of processing. And this would be in the for scope now. Wait, no, the type expression, yeah. Okay, and then we also actually run the source itself. I think we do that first. The expression itself, we're checking that, and then we get the type, and then we run the binding pattern. So at this point, the for scope should have all the bindings in there, all the declarations in there, and then we do run block for scope for expression body. All right, that is all of the expressions that we had there. So potentially now we could run, well, we don't have these doesn't do anything right now. I'm just gonna remove these so we just don't get the error messages anymore. Also, this one doesn't return anything, so oops. Let's just do like this should return a result, so I'm just gonna return an empty thing here. Okay, so potentially now we could actually call type check to get some diagnostics. So what I'm gonna do is, well, let's go to run script. Here we're parsing the thing, and after that, we parse the imports, and after that, well, let's do this. If we have like type check only, we need a type checker. Type checker. Okay, so let's go back here. Let's create the type checker here. And the script is script AST. This const. We have to make it into a var. Alright, so here's our type checker. And then we can check. Then we can do, yeah, just type check. Catch. Type checker error. And yeah, let's discard the result because it's empty anyway. And then we also do defer, type checker, deinitialize. There we go. So the arena gets deinitialized there. Yeah. So now we need to do this. Type check only. I guess we could just set it to true, force it to be true. So what should we test? I guess we'll just test this. This should be like an error somewhere. Okay, we got to type execution. No. Okay, so we have some errors. There we go. Must handle all. Okay. Let's do unsupported statement. Actually, we could just do return, to be honest. There we go. Identifier found. Okay, I think all of these are gonna be like that, so just do this. Find the pipe, add a thing. There we go. Except maybe for something. What is happening here? Yeah, I never added this error. Then scope, try, else scope, try, stage, found const. Oh, these are const. Okay, fine. So then you are const as well. String literal. There we go. Okay, fine. You are const. I wonder if this makes the expression const as well, because we actually want them to not be const. Yeah, I think this makes the expression const, or maybe not. No, that's okay. So this is a pointer to a mutable. Okay, good. Good. Scope is not marked public. Yes, it is. Oh, I see. Now it is. Wrong file. Result type we need an allocator. Yeah, self. Try. Is that it? No. Result type. Type expression. What is this? Okay, whatever. Let's do this. Oh, right. So we actually, okay, we need to allocate this function type. And then return. There we go. Cannot enumerate values of that type. Cannot enumerate values of type. Okay, I see. Now we get a whole bunch of errors here because we're missing a bunch of result types functions. So I'm what's happening? Expected identifier already out of memory. Type expression found binding. Oh. Well, if we didn't find it, that's weird, but okay. I guess we'll return this. No field, remember, okay. Now we have this, so let's just copy this part, go to path, add it here, return null. Actually, let's do this. I'll just return null on all of these. The block, just to have it. Capture clause. Okay, which one do we need? Literal. Array literal. Map literal that we don't have. Pipeline. this one that we don't have. Member expression. Index expression. Yo, piano coder, yes. We're chugging along. I'll just add all these stubs. Oops. Just to get something running. Binary expression. Could have also started with just the one in the inline, like have the inline else resolve in an error or something, or a null, and then just have the actual ones that we support, like 1 or 2 or whatever. Or whatever. Function literal that we don't have. Good. Async expression. I'm just gonna delete these, I think. Yeah. Okay. That shut him up. No, it didn't. Okay. If expression. Show keyboard. I don't know. Probably not gonna have a camera ever. We'll see. All right. So. Okay. Now it's running. Or I mean, it's doesn't report any errors. So let's see. Identifier not found. Hey! Script execution error. Why do we get script execution error? Type mismatch. Wait, does it still go ahead and... where's the thing? Okay, one last thing that I want to try. I want to try to hook it up with the LSP, and we'll just try it. Like every time a document is updated, we run the type checker and see what we get. Now, but we don't have like any. I guess we don't have like the type. We don't. What am I trying to say? We don't have the type. Ah, here we go. Return success. Return 1. All right. Yeah, identifier not found, but we're not seeing where it is. So we need to add this. We need to add something like this to that. Like it could be either through the type checker, kind of returning what expression had an error. It could also be that that should be it, I think. Yeah, because we're supposed to be able to use this in the LSP So let's store expression, like error expression, or expression that errored. I'm gonna change this later anyway, so whatever. Yeah. It could also be a statement, but whatever. Let's do optional, set this to null. Now the issue though is that, okay, we're gonna have to hook this up everywhere, basically. I think what I want to do is I want to have a function called like report expression error, where you have the expression basically, and that's it. So we're reporting this error, maybe together with some kind of error type, and yeah, so this will be void. And what I'm trying to say is that basically every time we are like in one of the inner parts and we want to report an error, we use this function instead. But right now I think let's just make this super contrived and just make this very specific thing work. So let's do self expression that error equals to expression. There we go. Now what kind of error did we get? We got like identifier whatever. So when we do this, we will do report error. And the expression is, oh, it's the identifier. Okay. Actually, you know what? We could just use the parent. No, we can't. We can't use the field parent pointer because it could be a different type. Actually, identifier exists on several types, so we can't do that. Okay, so maybe we don't do it in here. Actually, then we will do it when we call it. We call it in like, is it like 1, 2, 3 different places. So it's not that big of a deal. Assignment. Now you are always going to be part of the expression. So I will grab parent expression. It's going to be field parent pointer. And the name is assignment. The field pointer is assignment, and this is going to be expression. Okay, now this only works if this pointer was actually part of an expression struct, where field parent pointer will give you the parent struct. However, if this is not part of a parent struct, this pointer, then this will be undefined behavior. But this is a nice way if you don't have the parent, but you know that the assignment will always be this expression. So you could get the expression like this with field parent pointer. But you have to use it with a little bit of care. And then we will do like catch here. And we'll return this error as well. And then we'll do report error parent expression. Actually, we could do this here and then the error is the error. All right. So now we. Okay. Okay, so this is always an error, I guess. Let's just do try here, actually. Expected error unit. Oh. Okay, well, let's do that. Does it complain now, even though... No, it doesn't. Okay, cool. So it's like I want the interface to be good so I don't have to change this later. So we report the error, but then we keep on going with the other stuff. Right? But now this will actually abort here because this actually does report an error. But later I want this to not report an error. Like I change this from return, and then we keep like a list of errors that we return instead. Okay, but now this is reported there. Where else do we have run identifier at? Here, which is member. I don't care about that. And this is assignment, and this is just expression, like identifier as. Okay, so let's do that. So only for assignments. And of course we get this still. But if we go to run script now, and we get an error, we get this error. And now we can do some stuff. So we can get this. I'm just gonna say or else unreachable here. So we have to get it. And then we can use it because expression has a span. Where do we have log span at? Executor. Let's copy that again. I'll put it over here, whatever. We need a span color. And we need rainbow. And AST. All right. Let's log the span. Rider is going to be that span, expression span, source is of course going to be, we need a document, which is document store, request. All right, let's grab the span here because we need it, because it says where the thing gets wrong. Span start file, try. So now we should get a document here, and then the source is going to be like document source. So document source, and then you are going to be the span. So now we should see the span there when this goes wrong. There we go. So now we're seeing the span. Why is it being printed afterward? Oh, I see. Should we flush? Whatever. Let's do standarder. Is that standarder print? There we go. And then flush. Okay. Whoops. New line. Okay. Identify not found. You can see the line here, But the point is that now we can go to the LSP and use this information as well. So let's go to the LSP. I think we go here. Right, rebuild symbols. I guess we need another function that will... No, let's... Yeah, okay, so we have the parser. We get the script. We should store that on the document, to be honest. We should store the AST on the document. Yeah. So that we can use it in the other function. Oh, we have it here. Is this used at all? Oh, it is used over here. Put cache. Oh, I see, okay. So after this, it will exist on the thing. Or after this, here. Rebuild symbol. So let's create a function called report type checker stuff. Yeah, sure. Let's create a type checker. Just as we did over at here. Let's actually just copy this whole thing. Okay. Script AST is going to be self AST. Okay. Now, I guess this would only be in this document, so yeah, so we catch the error, we get that, we get the span. It has to be this document, so it's kind of weird that we would, yeah, it has to be this document. So we'll just do this, and then we can do, I think, is it workspace? No, it's self-diagnostic something. Clear. I see. The parser actually puts things in the diagnostics. Okay, well, we'll append something here anyway. The item is a diagnostic, so let's look at that. We need these things. Right, do we have this? The message, let's just do like error name span. It's going to be expression span, so we need dots here. Severity is going to be, is that a thing? Where's the syntax error at? Okay, there we go. Oh, okay, I see. It has to be like this. Error. There we go. Now, workspace, detail. Yeah, okay, we don't need those. So let's go here. So we're doing rebuild symbols. This is on update. So let's do try report type checker. Now hopefully this is this an arena? No, I don't think so. I don't, okay, we'll find out, I guess. And then we'll do it here as well, except this is for the workspace. No, this is entry value pointer. No, wait, but this is the open or replace. Yeah, okay, fine. URI. Wait. Okay, that's fine. Okay, there we go. So do we get it now? We do like sig build. Actually, I will just restart the whole thing. Let's open up this. Oh, yeah, it works, except it like crashes. But yeah, it does work. Woohoo! All right, but yeah, that's all I have time for today. So awesome, we got like the basic type checker in place. We'll see how much of this we're gonna have to redo later when we actually try to get stuff like working. But I mean, we do have like some kind of basic type checking going on, some kind of basic like semantic stuff going on before we actually run the actual script. So that's really cool. So yeah, so it's gonna have to get like improved later, but yeah, that's gonna be it for now. Let's see, a question here. When you open the broadcast, do you have specific hours? No, I mean, well, okay. So I basically try to, well, it's gonna be like at my time around 9 a.m. or 10 a.m. or something like that. Hopefully, it's kind of different from day to day. So it depends, but yeah, it depends on, you know, how much workload I have and other stuff. So so yeah, you just have to get lucky, I guess. But yeah, that's gonna be it for this time. So yeah, thank you very much for joining me, and I'll catch you later.